discuss about Java cryptographic extensions in this particular module. So in this lesson, we are going to learn about what is cryptography, what are the different areas where the cryptography is very popular and why it is important. Then we will discuss about something called AED, which is more about authentication scheme. And then we will talk about Cha-Cha-20 stream cipher and Poly 1305 authenticators. Then we will discuss the same algorithm, the Cha-Cha-20 Poly 1305 with a sample program. That would be the objective of this lesson. So before we move on, first of all, understand what exactly is a cryptography. So to give you an idea, cryptography is a science which deals with these encryption techniques. So when I say encryption, that means given an information, if you want to convert in a form so that normal people cannot understand, that means they cannot infer easily by looking at your text. That's called cryptography science, which help you to do that. And what cryptography as a science contains is, it contains a set of these encryption algorithms which help you to convert a text in a form where people cannot understand easily. That's what the whole point of cryptography existing. And if you look at cryptography, the entire science of cryptography is more about different types of algorithms and these algorithms with different encryption techniques, all that. Now, if you look at the generalized definition at internet or whatever, sometimes you see instead of cryptography, people call it as cryptographic system or cipher system. So generally the plain text, that means the text which you want to convert, that's called as a source text or plain text. Whereas when you convert the text using some encryption algorithm, that particular converted text or text translated form is called ciphertext. And the algorithm used are sometimes the encryption algorithm I mean, or sometimes called as cipher. So like I said, it's nothing but a method of hiding data so that normal people cannot view it just by like that. And if you want to convert that original plain text to encryption text or cipher text, you need certain encryption algorithm. And cryptography have a lot of algorithms to do it. And some of the popular ones are like AES, SHA algorithm, MD5, whatnot. You have RSA, you might have heard, that also comes under cryptography. So basically, entire cryptography revolves around certain things. Like, when you talk about cryptography, it's about a plain text exists that gets translated by an algorithm to another form, which is ciphertext. And these are done through using some ciphers, which are nothing but encryption algorithm. So the concepts of keys, algorithms, ciphertext, plain text, these terms you hear now and then. Now, if you look at overall cryptography, at least at a high level, if you look at based on how they behave, there are two types of, you know, at a high level, two types of cryptographic algorithms are there. One is symmetric, another is asymmetric. Sometimes if you see some of tutorials or whatever, they also introduce one more, which is called hash functions. So these terms are very much important because we use this symmetric, asymmetric now and then in this particular lesson. So what exactly is symmetric algorithms or symmetric encryption algorithms? So symmetric encryption algorithms are where both sender as well as receiver. Sender is the one where you encrypt the text and giving to some of the information to your friend, and your friend is the receiver. Now, when you are encrypting the information, it is like you're putting an encrypt of the data in a form so that nobody understand and giving it to your friend. Now, your friend have to decrypt it. Then only he can see the message which you are sending, right? So, sender in this case is you and receiver is your friend. When you want to send it, if both of you are using the same key, then that type of algorithm is called symmetric key encryption algorithm. That means you are using the same key in order to encrypt as well as decrypt. Okay, this is called sometimes single key or one key encryption techniques, but the most popularly used term is symmetric key encryption technique. Whereas in the case of asymmetric key, what really happens is you have two keys. One key to encrypt the information, which is called as public key, another key to decrypt the information, which is called private key. Public key is open to all, no problems there. Like even if you go to somebody, maximum they can encrypt. But private key is the one you have to secretly send. And that is where the entire challenge comes. When you say secretly sending it, what if somebody gets that private key, all that? And that has a different discussion altogether. But understand, asymmetric encryption algorithms is more about having two keys to encrypt and decrypt the information. And here, in the case of symmetric key encryption, one challenge always there is how you do the key sharing, because your key is going to be common. Those are the things. Just remember, these are the things we have it. And like I said, in addition, some of the books or articles talk about hash functions. Hash functions are basically these cryptographic hash functions are used to verify your digital signature and all that. And hash functions is nothing but, where given an information, they convert in a form where it is also encrypted form, but just that you cannot deconvert or you cannot decrypt. That's because that's the part of the hash function. That means once you convert it, that's it. It lies in that form as it is. Now you might be thinking, okay, I encrypted. If I don't have a way to decrypt, what is the use of it? The use of it is, if you want to compare again, you need the original text. Let's say I have a password name ABC. Now you encrypted a MBC to some form. Now you want to compare whether somebody has given the same ABC. Then what you have to do is you ask the same input source input information and again convert, and you will compare that encrypted text with the encrypted text you have. That is how the things are done. In fact, the digital signatures are done like that, where once you sign a particular document or whatever, they also will verify with whatever, the same algorithm which you have used, and see after signing is it giving the same information or not. In fact, not only in digital signatures, even some of the operating system, when they store user passwords, one best example is Unix, where it will store this information using this hash functions. And in hash functions also, there are like too many varieties. Like you have SHA, which is called secure hash algorithm, which is very popular. Apart from that, you would have MD5, and each have different types of message dials they produce. So that's more about cryptography. I hope you have enough context on what cryptography is, what are the terms we use, why we talk about all that and all. So apart from that, you might sometimes hear about a term called steganography. Steganography is not related to it, but it's an extension to this guy. So steganography talks more about how you hide information. You will be encrypting, but at the same time, you will be hiding information behind some images and all. That's what steganography is. But cryptography, just keep in mind, it's all about science of different encryption algorithm and how to use it, how to share the key, all that. And coming to these things, like how it is popular in computer network and internet security, like computer security, if you want to secure your computer, you need some collection of these encryption algorithms. Even though you don't know, some of the security tools in your system, like not an antivirus, whatever security algorithms are there, they use some or other encryption algorithms to protect your data from your hackers. In fact, big organization like Flipkart, Amazon actually encrypts the data of their employees automatically every other time using some encryption algorithms. Network security, because you want to send data over network, obviously it has to be secured. So again, it uses some kind of encryption algorithms. Internet, same scenario, just that you will be traversing this information over multiple connected networks. Now, we discussed about it. Cryptography is nothing more about a science of using converting your information in a form where users don't understand. And this can be in different forms, whether you can do substitution, transposition, product. It could be of any of the operations you can use. There's no limited. Most of the times you see cryptography actually uses a lot of bitwise operations, like your AND operation, OR operation, XR, all these operations in cryptography uses a lot. And like we discussed about, if the keys are single, that is called symmetric encryption. If you use two keys, that is called public private key. And your RSA algorithm, which is a popular one, comes under asymmetric key encryption technique. And we discussed about it. What is cryptography? It is converting plain text in a way such that users don't understand your message easily. And let's understand what is the main aim of cryptography and why we are doing it. The main aim of cryptography is to ensure the secrecy of the data, and also secrecy of the data as well as the algorithm used. And when you say a good security algorithm or good encryption technique, that has to be providing basically three functionalities. One is confidentiality, another is data integrity, and one more is authentication. So when you say confidentiality, it just means that data is read only by the authorized parties. That means the data, if you are intending to be read only by a receiver or your friend, he only should be able to read it, not everybody. When I say data integrity, it simply means that data is not altered in between the sender and receiver. That means once you send the data to your friend, in between it should not get changed by anybody like an intruder or hacker. And authentication, and that's what going to be our one of our key discussion in this particular lesson, where you ensure data is actually getting from the sender. That means it is not modified in between by somebody where you don't know, but you are thinking that is a correct information, but actually it got modified. That shouldn't happen. And that's very, very important. And that's why we are going to discuss about how you not only encrypt your information, but at the same time, how you ensure it is properly coming from a authenticated party or original receiver. That means nobody should be disturbing in between. How you ensure that's not happening. If you see in Java, Java 11 provides support for two types of encryption algorithms. One is your Cha-Cha-20 stream cipher, another is Poly 1305. These are the two popular ones. So actually, Poly 1305 is the authenticator, whereas this guy is your encryption algorithm. So why you need to? If you ask your question yourself, this guy is for doing encryption, and this guy is for ensuring this information which you encrypted is not modified by anybody. So that authentication. So like I said, the third factor of cryptography rule, where the data is originating from only a particular concerned party, is what this guy ensures by using the MAC and all that. MAC is nothing but message authentication code. Now here you see the term stream cipher. So what exactly is stream cipher? So again, in symmetric algorithm, you have two types of things can come when you're talking about symmetric encryption techniques, which is stream ciphers and block ciphers. So cipher simply means algorithms, by the way. So in the case of stream cipher, what will happen is you try to convert one symbol of plain text directly into another symbol of plain text. That means given a text like A, B, C, if you convert A to B and B to C and C to D, that means you are converting one symbol at a time to another form. That's called stream cipher. In the case of block cipher, what will happen is you will not convert one character at a time or one symbol at a time. Rather than character, I should say one symbol, because it's not necessary that you have only character. You can have punctuation symbols, numbers, anything. So it is all like one symbol at a time. If you convert, that's called stream cipher. Whereas rather than one symbol, if you're converting a group of text or a block of text, that's called block cipher. And all your simple substitution like brute force cipher and all that does this stream cipher only. And your Java 11, which provides this Cha-Cha 120 and Cha-Cha Poly 1305 ciphers, these are all called stream ciphers. So what is this AE or AEAD? So basically AE means authenticated encryption. Like I said, it actually tries to honor the principle that once you convert the information to some encrypted form, how you ensure that it doesn't change in between. How you can guarantee that, yes, this is the information I encrypted and nobody changed it. That is what you actually ensure using this particular Poly 1305 algorithm. So basically authentication encryption, or sometimes we call authentication encryption with associated data. That AEAD is that AE stands for authenticated encryption, whereas AEAD means authenticated encryption with associated data. The main aim of these guys is to ensure the encrypted information comes as it is without getting modified by anybody. That's what the main theme of it. So how they do it? So what would happen if you look at generally how the attacks happens is the hacker, what they generally do is whenever they try to decipher or try to understand what is the algorithm you used, they actually compromise your cryptography, whatever algorithm used, by passing some kind of encrypted text which they already know what would be the answer, and they try to understand from the encryption algorithm how that is behaving. So based on the behavior, they actually try to crack your algorithm and get the answer. Whereas this kind of AEAD schemes, which is what your Chacha 125 and Poly 1305 uses, it ensures even though somebody tries to compromise it, it will not happen. That's what the main aim of this. That means it is ensuring once your data is encrypted, nobody can come as an intruder and do these kind of tricks in order to understand your algorithm and crack your algorithm. So like I said, this is what it talks about. We discussed more about it. And like I said, when these two guys combine, they actually do this authenticated encryption with associated data technique. That means they are saying we are encrypting that, not only encrypting the data, but also ensuring the authentication such that nobody can change your data. And this AEAD scheme, that means the combination of Cha-Cha 20 and Poly 1305, actually takes a 32 byte as an input, and further what it does is it generates a secret key. It actually gives you a secret key and a 12 byte nonce, a variable and a variable length plain text. That's what it takes. And what it does is it actually gives you a plain text which a variable length associated data, and that actually, when you encrypt it, it gives you a ciphertext. When I say ciphertext, the encrypted text. And finally the information will be a 16 byte tag. We will look at all that with a programming example. Just understand this is how the flow goes. What is Chacha 20? So first of all, you are seeing the 20, right? 20 here indicates the number of rounds this particular algorithm do. So there are other algorithms like Chacha 80 also. That means they will do 80 rounds. That means your algorithm runs that many number of rounds. That entire steps will run that many number of times means by that. Now, Chacha 20, like I said, it's a stream cipher. It is designed by a scientist called Daniel J. Bernstein. And this is a variation of the earlier family of stream ciphers called Salsa 20, and it is widely used in order as an alternative to AES. AES is another algorithm which is part of cryptography. AES stands for Advanced Encryption Standard. Before AES, there used to be an algorithm called DES, Digital Encryption Standard. The AES become much more powerful after DES was not doing well. I mean, not working well. Then AES have come, and this AES also have this lack of authentication not happening. That means the authentication factor is not very well happening there. That's why this guy has come in. And this 20 round stream cipher, which is what called as Chacha 20, the 20 just indicates it runs 20 rounds of the entire algorithm. It's very faster, and it's very sensitive to timing attacks compared to your AES algorithm. And Java 11 have these algorithms support, and you can see you have packages which support this algorithm. And basically Chacha 20, if you see, it is mainly used for encryption. How the way it works is it has a pseudo random generator as part of its code, and it actually based on that pseudo random generator, it actually do some kind of add, rotate, XOR operations multiple times, which is called ARX. And these are all CPU friendly instructions. Since they are CPU friendly, your performance will be comparatively faster. And if you want to generate ciphertext, that is actually done by doing a lot of XOR of your plain text with the pseudo random number generated. So that is how the high level flow of how it works. And currently your JDK now supports a 256-bit of this Chacha 20 cipher. Again, all remember that encryption algorithms actually uses different schemes. Like some algorithms might use 50 bits, some algorithm might use 20 bits, some algorithm might use 50 bits. And in the case of Chacha 20, it uses this 256 bit. That means the key length must be of that much size. That's what it means by that. Poly 1305, if you see, Poly 1305 is an authenticator which actually takes a 32 byte key and a message, and it produces a 16 byte tag. So the 16 byte tag, if you remember, I said 16 byte tag it is going to happen. That 16 byte tag is this. Okay. And it is actually based on, this guy generates based on the polynomial evolution of your prime field 2 power 130 minus 5. And it takes, like I said, 32-bit key and a message, that means your plain text, and produces a 16 byte tag which looks like this. So each indicates it's a 16 byte tag. So each one, it produces 16 byte, where each of them could be possibility of 128 bits in that. And this tag is actually used to authenticate whether your message is correct or not. So understand like this, using Chacha 20, you encrypt your information. On top of it, you apply this poly 1305 so that your message is authenticated, so that no intruders can hack your message and identify and mess up with your data, and you are not aware. That's not going to happen. So using the same key to generate tags for multiple messages, if you look at the earlier schemes, it actually helped these hackers or to forge your messages, which is not possible with this. And this poly 1305 is already also given by the same scientist who introduced this Chacha 20 stream cipher, the Daniel J. Bernstein. So this tag is very important to authenticate your message. That's why what they have done is one algorithm for authenticating, another algorithm for encrypting. This guy does the encryption part and decryption part, and this guy does the authentication part, so that the message forging is not very easy. What does it mean by authenticating the encryption? So if you look at earlier, if you want to authenticate the message like digital signature and all, what people used to do is they used to use this hash signatures or hash functions. The hash functions are mainly used to authenticate your message, to say that okay, nobody modified. That's why I said it is used in digital signatures as well as password encryption in operating system. The same way here your poly 1305 works. That guy actually generates some message authentication code which is of 128 bits and append it to your Chacha 20 encrypted text or the cipher text. That means, like I said, the Chacha 20 does the encryption part, and this guy adds some more information so that you know that this nobody modified. And again, during decryption, this algorithm checks the MAC to see that if nobody modified, that's how it happens. That's what I mean by authenticating. So just understand one algorithm for encryption, another algorithm for authenticating. And if you have a question like why you can't use SHA-MD5, that is actually uploaded on the entire file. but it has their own compromises because there is no hybrid algorithm that says using SHA I can combine. But these guys have come up with a powerful algorithm like the earlier ones, AES and all. And they also introduced this Poly 1305, which provides better authentication than the previous MD5 or SHA algorithms we have. The combination of these two, the Cha-Cha-20, which is for encryption, and Poly 1305, which is for authenticating a message, the working of these two is to encrypt and decrypt messages, then finally add the nonce to the final encrypt tester. This nonce is your MAC test. NONC is there, right? That is nothing but your MAC test we talk about here. That is gets added here so that once while you're decrypting, you really know, okay, whether the encryption is coming from the right source or it is modified and all. It's okay that even if MAC somebody knows because you already have this information properly encrypted. Now coming to this guy, the way this guy works, the combined algorithm, the hybrid algorithm, the way it works is it takes a 256-bit secret key, which we already spoke about earlier. In JDK11, it supports a 256-bit key, and it takes a 96-bit nonce, which is your MAC code. And by default, the initial counter begins by 1, and we don't need to mention any value there. Now let's see the sample program. So the sample program is divided into two parts. So first part is where actually you write all your encryption. You can see this is your encryption algorithm, and you write your decryption algorithm. So this is your encryption algorithm, and this is your decryption algorithm. Okay, and you write the functions you require, like you want to get nonce, that and all you write here. So, but if you see, this algorithm is mainly for encrypting your data, decrypting your data, and getting the nonce. Once you have done that, there is another program written where that guy will pass this information and make use of the encryption and decryption algorithms written and show how the data is converted, how the data is changed in between. And this guy also needs some help using some other function which we have written here, something like convert bytes to hex. That means the bytes are converting to hex, and it also have to generate a key, because if you remember, our key should be 256-bit, right? So that is what this guy gets it and passes to it. So let's start with the first one. So if you see, in order to write your encryption and decryption algorithm, the first part is you have to import this particular secure random algorithm. Then you are saying which algorithm to use it here. Then you are saying your nonce length. What is the length of your nonce key, which is 12. Then you actually have written two functions. One is encrypt without a nonce key. There is another encryption algorithm with a nonce key, if you observe clearly. The plain text is there, secret key is there, nonce is here, but here there is no nonce key. When there is no nonce key, what this guy will do is it automatically returns you an encrypted text with plain this, and if you see, it indirectly makes call to the same function. That means even if user don't pass this nonce key, when you're calling this function, it actually generates based on whatever plain text secret key you have given, it actually calls the get nonce function, which is what we have written. The 12 byte, it automatically generates it for you and do it. That means even though you don't pass the nonce key, this function, which is an overloaded function, automatically calls this function. So this is the guy who is doing the main job. So what this guy does, he actually creates an encryption algorithm instance, which is in this case, this Cha-Cha-20 poly 1305. After that, he is creating a vector based on the nonce key. Then he is initializing the algorithm with your encryption mode. Encryption mode is nothing but you have something here, right? Like your encryption algorithm, and he's saying cipher dot encrypt mode. Then he is using the key which you have passed. Then the vector you have generated. Then finally he is trying to generate a encrypted text here. Then on the encrypted text, if you see, we are adding this nonce length, which is a 12-bit one, 12 character length. So we are adding it. Then we are putting both encrypted text as well as nonce. Now that is what you return to user. Now this 12 is what the MAC text or the poly 1305, the one we are talking, right? Like some message authentication code will be added. That is what this is. This is about encryption. Now let's talk about decryption. When you do decryption, you need the cipher, that means encrypted text, as well as the secret key. When you have this, what we are doing, again, we are creating byte buffer because that is how we have encrypted it. So we have to do the reverse here. Again, you are wrapping the entire ciphertext in byte buffer. Then to get encrypted text, if you closely observe, you know the C text length, and from that we are minusing the nonce length. That means we are just taking out this piece which you have added after encrypting the data. Now, nonce length is this, nonce length data, nonce length character is this, the additional data added to ensure it is authenticated, and this is the encrypted text. Both are separated. Now you are again getting the byte values of these two after doing it. Once you get that, again you are getting the cipher, which is nothing but encryption algorithm that this means, which is this. Now after that, again you are creating a vector, and this time you are saying decrypt mode. If you observe, earlier we said encrypt mode, that's where it encrypts the data. This time you said decrypt mode by giving the key and a vector, and this produces a decrypted text for you. This is how it actually generates a output, a decrypted output for you. So what we did, using one encryption algorithm, first you encrypted the data, then after encrypting the data you added some MAC text which is nonce length to it, and while decrypting you separated this nonce length, which is the additional code it is added, which is the MAC code, and that gets removed from the cipher text, and after that they are dealt separately, and you are converted using the same algorithm, but in decrypt mode you actually get the plain text data. So that is how these algorithms work. Now coming to the original one, now you haven't, we just discussed about how this works. Now let's see when you pass the data how this happens. Now here is where your input text is, and here is your nonce length 12-bit and your MAC length 16-bit. Now these are the ones you need to import here, since we are going to use all this up to secure random. Now here, if you first observe, this is our plain text, Java and Chacha 20 poly 1305. That is your text. You created an instance to it, which is what gives you the cipher. And this, if you see, this is nothing but Chacha 20 poly 1305 is this class. That means you are creating an object to that class, because you have to call that encryption and decryption, right? So you need to create an instance, right? So you created. Then after that you are getting the key. So this get key is part of this function. If you see, this is where this guy, when you call get key, it gives you a random for this particular instance, it generates a 256-bit key for you, and that's what you get here. Once you get it, you are printing whatever is the input, which is this. Then you are printing after converting this input to hex, because it needs the information in hex, so you have to convert it. And that converting bytes to hex function is here, where for any given byte, what it will do is it will convert given bytes to hex and translate to string and return it back to you. And this is where you are printing what is your encrypted information. After encrypting what is there, then your hex code you have converted using this convert bytes to hex, that is what it is giving. Now after that it has to print the MAC and nonce, right? So that is what happening here, where you are wrapping this in a buffer and by using your ciphertext, and from there you are getting how many bytes are there, and this guide bytes is part of this input one function. And after getting it, you are saying this is my nonce information, and this is the byte information, and this guy will give you the original ciphertext message, and this guy will give you the MAC as well as nonce, and finally you are filling the ciphertext. And finally you are trying to show it. If you remember, if you see closely, this part is entirely showing how you encrypt the messages using the algorithm which you have written, using the class you have written in the earlier PPT. Now after doing that, now you are showing that what and all steps will happen one by one by doing this. Once you have done that, now at this time you are showing the decryption. Decryption is just the reverse process. Whatever you have done, you will just go backward. First you convert bytes to hex, then you get the using decrypt mode, you actually convert your ciphertext and key. This function is part of the previous class we have written. And once you convert, you are printing the encoded one, and you're just showing what will be the decrypted form at the end. So finally, if you look at, if you see, this is your input which you have passed, and this is your input hex code. If you remember, we converted bytes to hex. That is what produces this. Then we started encrypting using our encryption code we have written, and this is the encrypted. This is the encrypted. This is the key, and this is the encrypted form of it. Similarly, we created MAC and nonce, and that is what being showed here. This is the cipher. The original text is converted to this particular encrypted form, and this is the one which actually is MAC, and this is your nonce. If you see, this has a different length. One is 12-bit, another is 16-bit, like what we spoke about, right? Kind of. So it is all converted to hexadecimal. That's why you see this numbers and all alphabets mixed. Then finally, whatever input you have given, which is your ciphertext, so that's what get converted by into the original form by using this plain key. And after decrypting, it looks like this. And after decrypting is not enough, because this will be an hexadecimal form. Again, you need to get into characters, which is what we have done here. So today we will work on some cryptographic algorithm in Java. Let me start the Eclipse. Okay, it's already started. Let me close these guys first. So this is my package, and this test is a project, and here is where I'm creating multiple packages. And in this package demo, let's create a class. This is we are going to discuss about one of the popular algorithm called Chacha 20 and Poly 1305. Actually, Chacha 20 is used for encrypting the data, and whereas Poly 1305 is not for encryption, it is to ensure the authenticity of the sender is identified properly without any, intruder. Even if something he changes the changes in encrypted text, um, you know, it shouldn't be possible. Like ideally, what happens is when you encrypt the message, there are ways to, uh, you know, change your encrypted message. So what actually these hackers and all will do is they'll play with your encrypted message by passing different types of, a trial and error kind of text, and understand how your algorithm works, and based on that they will crack it. What this Poly 1305 will help you is it will help you so that it ensures that this kind of the intrusion will not happen. So it protects like that. So we have one algorithm where they combine cha 20 plus Poly 1305 both, so that your message is not even just encrypted, but also it is like properly, what to say, properly authenticated. That means you will know that if somebody messed up with the message, if somebody tried to crack your message, so that is what we are trying to do here. So for understanding these cryptographic algorithms, even though I write code in Java, you need to have a good understanding of the pseudocode of how this cha 20 and Poly 1305 works. That will give you fair understanding. But with Java program, it is just like I'm implementing the pseudocode of it. So let me write the first code. So this is test cha 20 Poly 1305. Now in this, first we'll start with our public static void main string args, and here is where our actual code comes in. So I'm going to make string input equal to cha 20 Poly 1305 program demonstration. This is going to be the text which I'm going to encrypt. That's the whole idea. Now the input is ready. You can take input from user also, by the way. Now we say cha 20 Poly 1305 cipher equal to new cha 20. This particular class we have to create cha 20 Poly 1305, and this particular class will have the the actual information about how to encrypt, how to decrypt, how to generate the nuance and all that. So let's create this file first. The name is cha 20 Poly 1305. Now this should appear, given that there is a, yep. Now here what we want is, this is like pure encryption. What needed, we'll write it here. We're just mentioning encrypt algorithm equal to that is our encrypted algorithm name. Then we have to define nuance, Nuance is like a random value. You can consider it like a random value. We are just telling what is should be the length of it. Then after nuance, we'll write the actual method. We are writing the encrypted methods. So encryption methods, which we need to use. We are saying this method will return exception, and it's saying secret key. You have to import the secret key and all. These are all actually certain packages we need to import. First, let's import java x dot crypto dot secret key. So what else it says? Add return statement. Okay. So this one we imported now. Once we imported secret key, now we have to say return encrypt of ptext comma key comma get nonce. This is the function. So here the idea is we need the nonce also. Nonce is like a random number, it gets added. So let's say if user have passed an encryption algorithm without passing the nonce key, just the plain text, ptext stands for plain text, and the key, and he didn't give nonce, which is required. That is the one actually being added to your text so that it identifies whether the message is identified by intruder and messed up or not. And if that's not passed, since that is important, what we are saying is we call the actual method where that is being done. That's what the whole idea is. Because user might not be knowing that nonce and all. If user passes, that's well and good. But if it don't passes, it's our responsibility to take care of clearing that nonce also. So this is where the actual encryption happens, where even though this is like a dummy method where it in turn calls the same nonce thing, just giving a privilege to user so that he can use anything. And nonce, and this also throws exception. It still says we need to implement get nonce, so we are going to implement it. And this guy says what? Encrypt ptext secret key nonce. Okay. Now we are going to write our cipher. Cipher equal to cipher dot get instance, and get instance we are going to use the encrypt algo. We already have mentioned what encryption algorithm we are going to use, and this cipher is not there with us, so it's already imported. If you see why this is an error, remove argument to match encrypt byte, return encrypt plain text. Oh, there is a plain text secret key throws exception. Okay, change method encrypt byte to remove argument. We'll see. Let's finish the entire code, then we'll see where and all the errors are. Most of them should disappear after writing the entire code. So once we have created cipher, and this is what we need to do now. Initialization. We need to put some initialization values. This IV parameter we need to import, and this comes as part of java x dot crypto dot specification dot, you see, this is the one. Once that is done, then we have to say, we have to initialize the cipher. Initialize with what? The encryption mode. There is this encrypt mode. Then we have to key the key. Then we have to pass the IV, the initial value which we have specified. Then after doing it, you have to say encrypted text equal to cipher dot, there is a do final method. So this will do a multi-part encryption based on how you initialize the cipher. So we said cipher in the encrypt mode. The same method we will use to decrypt. So here we are saying encrypted because we already said the encrypted mode. So we are using this do final and asking it to continue with the encrypted mode which we require. So, and in encrypted also you have to pass the text, which text you want to do. I gave the plain text which has the information about what to encrypt. Then once it is done, now we have to say output equal to byte buffer dot allocate, and here we need our encrypted text dot length plus the nonce length dot put encrypted text dot put nonce. Just adding to the encrypted text whatever the nonce created. We'll create the nonce also now. Now we will return the output. This is what our encryption algorithm is. Why this still gives an error? Remove encrypt, return encrypt. Okay, what does it say? Remove arguments to match encrypt of byte. Should be correct only. Return encrypt pretext comma key comma get nonce. Why it still shows error? Okay, let's write the get nonce also. After that it should get resolved. Get nonce is already there. Okay, now write the get nonce first. Get nonce is should be, it shouldn't be just this. It should be static byte get nonce. Yeah, that's a problem with the get nonce. And here is where we are going to generate that random value which I was talking about. New nonce equal to new byte 12 and say new secure random text bytes new nonce return new nonce. And we need to import the secure random also, which is not there yet. So that is what this might be complaining. So javax dot security dot secure random, and we need that ny byte buffer, that is also imported. Return new nonce, it should be a variable. That's it. So now it looks good. No errors. Now let's start with the decryption function here. Decryption function will be byte decrypt byte ciphertext comma secret key. So you are taking ciphertext. Ciphertext is nothing but the encrypted information, and algorithms sometimes are called ciphers in cryptography terminology. So we are saying throws exception. So we are saying byte ctext secret key throws exception. What does it say? Add return statement. Okay, we'll do that. Now here is where we are using byte buffer equal to byte buffer dot wrap. And what we need to wrap? We need to wrap the ciphertext. We are just creating a byte buffer for it. Then, if you remember, in the encryption, we are adding the nonce to it. The random value we are adding to it. If you see, this is where we are adding. And those and all after initializing, you have initialized and passing it. Now, when you decrypt, actually you have to take this out. You have to strip this out. So that's why all this we need to do. You can see that that's what we are trying to do here. So we are calculating the length and everything so that we exactly derive. We need the nonce length for this. We should know the nonce length, otherwise you don't know from which message to which message you have to strip it out. Now once you have done that, now again this encrypted text, again you have to get the nonce, which is byte. What does this say? Nonce length, change nonce length. Oh, it should all be capitals, right? Nonce length, yeah. And now you have the nonce length. Now you have to get the encrypted text. That's what we are doing here. Now you have to get the nonce also. Now you got it. Now you're saying cipher dot. If you see, this step is same, just that the mode at which you are saying that need to be changed. We have done the same step in encryption also. Encrypt algo. So we are just setting the instance saying cipher dot get instance, this encryption algorithm I'm using, and we are saying I parameter. If you see, these are similar to these steps. If you closely observe, is exactly the same thing. We're not going to write anything new. The same thing we are going to write, just that when you are initializing, it just sets your mode. Here we are going to say decryption mode. That's the only difference, but the same lines. If you notice, these two lines are same as this. So because you are using the same algorithm, just that you are running in different modes, one in encryption mode, another in decryption mode. So if you remember, we have initialized saying this. So the same initialization will come here as also. Just that here you say I want to decrypt it. So this will not be encrypt mode now. This you are going to say I want to decrypt. That's what you're going to say, decrypt mode. So you just change the mode. Okay, there seems to be a problem. What does it say? Cipher. Okay, I think I missed these two lines, same lines. Now, once you initialize in decrypted mode, now you have to decrypt it. So this is where you are decrypting. Now for decrypting, again you will say the same thing, like just like how you said encrypted test equal to cipher.doFinal. The same thing here, cipher.doFinal, and you will give the encrypted text which you have received from user. Now this is done. Now once you get this, that's it. Then output. So your encryption, decryption, if you understand encryption properly, decryption is same. Just these two lines, and you are setting the mode using cipher.init. After that, you are getting it. That's all. So output, you are getting it. That's why you are allocating buffer. This and all we have done earlier. That's all. So when you're decrypting, you're just taking out the cipher from it. I mean, nonce from it. Now, given these are done, let's go back to our main program. So this is our main program. You have just created a class to this, your object to this Chacha Polith 1301305 class. Now this is what we are going to use here. Now here we are going to say my secret key equal to get key. And secret key is not there here. That's what this is complaining. So we'll do the get key also. Now we'll say system dot out dot println, and we'll say input. This is your input, and we'll say plus our input. Then we are going to convert input to a hex form. It needs it. So for that we are going to write a function called convert bytes to hex dot get bytes. So that's already available function. Now this will definitely be complaining about implement that method. And this is where we are going to write the hex bytes function. And this one will be complaining about the same. Let's implement these two first. Let's start with get key. So it says private static secret key get key. You should throws no such. No such algorithm exception. This is all we need to import. This will not be there for sure. See, import no such algorithm exception. Then what else it's saying? Import secret key. That is also we need to import. So whichever it is asking, I'm just importing. So what else it's saying? Add throws declaration, which is already done, isn't it? It's already done. So here we'll make it a general exception because there are other exceptions also. Now this looks good. Now we'll write the get key method mainly here. What does the get key do here is it generates a key for you. Key generator key gen equal to key generator dot, there is this get instance, and this is where we are going to say what is the algorithm we are going to use, which is cha-cha 20. The 20 actually indicates the number of round the algorithm runs, and here also it has something called initialization agent dot init, and this is where we are going to say 256 how many bits you want, then secure random dot get instance. Okay, we want the get instance strong, not this. Get instance strong, this one we want, and that's it. So now after that we're going to return the key, which is keys in dot generate key. That's it. So what is the error it says here? Keygen dot init get instance. I think there is one more extra parenthesis. So the key is good now. Now let's start working on the convert to hex byte stuff. Now here, this is just going to return you any given bytes. It's going to convert into hex and gives to you hex values and give it back to you. So here we are going to write our labeled or for loop. We are saying result dot append string dot format %02x. So this is the hexadecimal value conversion specification. So we are saying convert to hexadecimal value, and we are just setting it, and the result will get appended. So each time what we are taking is each one byte we are taking, and we are getting the hexadecimal value. The conversion specification is x, so we are getting a 2-digit hexadecimal value and keep appending to result. And that result, once it comes, you have to convert to string and send it back. So that's what we have done. The convert to bytes is this is what it's going to do. Now these functions are ready, input hex and all. Now we are going to write our encryption stuff here, system.out.println. Encryption. So we are just showing the encryption part here, and in encryption part you have to call that respective method, right? So we are saying byte ctext equal to cipher dot encrypt, and here we are going to use input dot get bytes. We already have get bytes written. Then you need to pass the key also. Key is same. We already have the key. If you see, this is the one. Then we should give us the cipher text. Now let's print the text also, encrypted text also. So we are saying system.out.println, and we are saying key in hex format. It's like convert bytes to hex, key dot get encoded. So we are just encoding the key and sending it back. I think there is an extra parenthesis here. Convert bytes to hex. Convert bytes to hex. Key dot get encoded. Yep. System dot println. Then the key we have encrypted. Now we have to see the encrypted form of the same hex. Convert bytes to hex. C text. Now this will give you the encrypted form of it. Now there are other parts. You have to print the nonce also. Nonce, like I said, it's like a random number, right? That also you need to print. So you're saying print MAC and nonce. MAC is nothing but message authentication code, which is what you added using nonce, right? That's what you are printing here. Now you're saying byte buffer bb equal to byte buffer dot wrap, and you're passing C text. So now your entire ciphertext is in this byte buffer. So from here, you're going to get the data. So now you say original C text equal to new byte input dot get bytes dot length. That will give you the actual original ciphertext length. Then you have to get the nonce. We know the nonce length. We already have defined nonce length earlier. So the same thing we'll use here. We'll say byte nonce equal to new bytes of nonce underscore len. We defined nonce length here. I think we missed to define it. That also we need to define. So let's define. I think in other program we have defined the nonce length. If you see here, we define nonce length. So that we didn't define here. Same nonce length we have to define here as well. I'm just copying from here. Nonce length we defined. And there is one more. There is a MAC length also we are talking about. That also we need to define. So I'm defining the MAC length also, the message authentication code length. And that should be of 16 bytes. Oh, what else this says? Change to byte. Okay. Now you got the nonce. Now you have to get the MAC also, right? So now MAC also same thing. New MAC equal to new byte MAC underscore len. You already defined the MAC length as 16. Now once it is done, now get the original C text. Now get the MAC. Now get the nonce. Now print the data back. Cipher original X value is original C text Then we have to print our MAC also. This is on your Mac. Similarly, we have to do the same thing for nonce also. It's going to be your nonce hex value. Then we say convert bytes to hex nonce. All these three is printed. Now we want to get the decrypted information. We are saying decryption. Now system.out.println input. Now this also we are converting to X. This input is done. Now we are getting the plain text here. Cipher.decrypt, and here you have to pass C text, that is your encrypted text, and key should be the same one. And once that is done, now you have the decryption information. .println key. You don't need to print this much, the key and all. This is just for your information so that you are aware what is happening, what is the key generated, what is the the encrypted and all. The main part finishes as soon as you write the main this algorithm. This algorithm is what you need to remember, how to write encryption and decryption. It is moreover same if you understand correctly. You have to just set the encryption algorithm modes, and when you're decrypting you have to take the nonce from it, that's all. But in this you're just printing each one of them so you're clear what exactly is the key after it converted, what exactly is the nonce and all. So that's why we are putting in detail. But while you are doing really the encryption part, you just need this one, and you might be hardly using to just encrypt and decrypt. You don't need to show keys and all, that's not required. Now this is showing you the key. Now let's print the decrypted text. Key hex, then let's say decrypted in hex format. Convert bytes to hex. Again here p text. Just converting to string. That's it. I think we are good now. No errors. Let's run this. So you see all this printing we are doing just for the sake of it. So first the input is cha-cha poly1 notifier. This is the one. Then we convert it into hex because the hex bytes it has to be passed. Then the same this convert to hex. This is what this key is showing. I mean the initial text is showing. Then on the encryption we are just converting the key to hex bytes, and the encrypted hex information looks like this. Then we have print the MAC and nonce, which is what we have done here. This part, MAC and nonce. After printing MAC and nonce, we have just printed the the input. What is the input given to it, and what is the key, what is the decrypted text, and what is the hexabyte. So it is like reverse. So actually when you really work on it, all you worry about just this encryption, just this part, and your key and nonce. Key and nonce will you will not show actually. You will just do it and leave it like that. You will not show what is the key and all, because the idea of cryptography is to not reveal the key. So you will not be revealing the key and all. You will be just working on and showing, okay, give me the input, I'll give you the output. That's all. So you will not bother about what is the key given, what is the nonce, what is the mag, that and all is not a worry for you. All you need to worry about is this algorithm, where you need to remember that your nonce length should be, you can put any nonce length, but here we use nonce length 12. And uh, your encryption and decryption, you should know how to write it. So all I did is, if you see, most of that is same, just that we have to run that in encryption mode and decryption mode. Before that, that initial values we have to set using the IV parameter, and you have to get the instance of that particular algorithm and all that. But otherwise it is more over same. And this is what we need to more worry about. And the input and all, you don't need to write this much. Just to show you all this I have written. That's all. I hope this helps. Thank you.
Let's summarize about what we have learned in this module. So this module is more about how to use cryptography in Java. So in this, we understood about what is a computer security, what is network security, and what is internet security. And we had a clear distinction and understanding about what they are. Then we also discussed about different types of authenticators we have in Java, like SHA-20 stream cipher and poly1305. Then we discussed about how a SHA-20 stream cipher in generally works, the pseudocode of it, like how it does, what and all things it does and all that. Then we discussed about poly1305 pseudocode and how that algorithm works, why certain rotations are needed, all that stuff. That's all. I hope this session helps and you will be able to write much more better cryptographic algorithm which are provided by Java by understanding this.
Hello everybody. This is Krishna here. So let's discuss about design patterns in this lesson. So what exactly is a design pattern, first of all? So why we need to learn it? So that's all we are going to discuss. In this module, we'll be focusing on what is design pattern. We'll briefly go on why it's necessary. Then we'll understand different types of design patterns we have. Then we will look at the three high-level categories of design patterns, like creational, structural, behavior. Then at the last, we will end with the J2E patterns we have. So before we discuss about design pattern, so what exactly is the design pattern is what we need to understand here. So design patterns actually are, well proved or already done or implemented solution for solving a specific problem or task. Now, you might be asking what kind of problems are that? Is it some specific problem or a generic problem? Now, the way it worked is like when developers started developing this code and all, so based on their experience and based on whatever situations or kind of requirements they get while they are developing, they have encountered that if you follow certain structure in your coding or if you follow certain approaches, the way you can maintain any project designed by object oriented can be better maintainable, extensible, and more stable. So it's all about design patterns is all about, the different types of approaches you do to design things while you're working on any object-oriented programming language and make the things so that it helps you to maintain your code for a longer time, reusable, and make it more scalable. That's the whole point. It is not something a language actually enforces you to do, or it is not something somebody asks you to do. It is something that when a project comes to you and you have these design patterns in your mind. So based on the project requirement, you have to say this kind of design pattern we use. Maybe I'll be able to get a better solution and I will be able to generate better solutions which are maintainable for years and all. So that's why it plays a very important role. So as I said, design patterns are not something it is like specific to programming language. Like I said, Java doesn't enforce you to do it, even though in Java people mostly use some or other design pattern to implement something. But it's more about an independent, structural pattern. Just like when you say, okay, if you remember, if you know, there is something called Six Sigma, which talks about how you can make your operation excellence things much better by following certain criteria. It is not an enforcement, but rather a recommendation or a best practice. People tell you that if you do this, maybe you can save a lot. Similar to that, the design patterns are like kind of conceptual, where it says that in any object oriented programming language, if you structure your problem like this, maybe you can make your project more scalable, maintainable, and stable. That's what the whole point is. So, like I said, using design patterns, you can make your code more flexible, reusable, maintainable, and sometimes more performance wise, more better also. So as a software developer, whenever you want to work on any object oriented programming language, these are the things you must know. And the advantages, like I already called out some of them, will be like it is reusable. So you can make the things reusable in multiple projects. And this helps to define your system architecture in a more better way. And these all captures the best practice of software engineering. And this actually provides a lot of transparency when you design an application. And since these are all lead to all, and also these all lead to you to successful projects, because these are something actually done by your developers who have experienced this problem way more earlier than you. That means some guy who was working on object oriented programming already implemented these design patterns, and they are being able to deliver successful projects, and they are the ones suggesting you to do that. That means you have a better chance of getting into the same path. And this actually helps you to easy your analysis, because when you follow certain structure, if you look at your entire SDLC cycle, that means software development life cycle, you can do even better analysis and requirement phase, because these are the things, it is like you can think it like, an experience shared by a lot of senior developers who said that if you follow that, this can be done, that can be done, and all that. So it is an experience you are using. So based on experience, when you are using, obviously you can make your projects more better. And in Java, if you look at the entire Java, the design patterns are categorized into two parts. One is the core Java design patterns and J2EE design patterns. We'll see both of them anyway in this lesson. So like I said, design patterns, the same thing has been written here. We discussed even brief. These are the best practices used by object-oriented software developers across the world. And these are nothing but moreover a trail and error kind of thing based on the experience, based on the research. What they found is these will help you to design software in a better and more efficient way. Now, what does design pattern actually talks about? The entire design pattern talks about how your objects communicate with other objects. Now, if you look at the entire design pattern, we keep on talking about this object, how it should talk to others, or this object, how it should interact with others. So the way you made it happen, that's what all design patterns is. And like I said, these are the three core design patterns, the core Java one, which is behavioral, creational, and structural. There is one more which is related to J2E specific design patterns as well, which we will discuss at the end. Now, types of design pattern, like I called out, these are the three ones: creational, structural, behavioral. These are the three design patterns basic to your core Java. That means all your core Java, whatever you are learning, it is specific to that. But if you go to advanced Java or J2E, the enterprise edition of the Java, they have different patterns anyway that we will understand at the end. Now, for each of the design patterns, we start understanding one by one here. So starting with creational patterns. So what is actually creational pattern talks about? So creational patterns designs actually concerned with the way how you create objects. Where when I say how you create objects, like when you create an object, it talks about different structures which is listed here: factory method, abstract factory method, singleton, prototype, builder, object pool. All this talks about how you can create objects so it can be used in a much better way. These design patterns actually help you when a decision need to be made at the time of instantiation of a class. That means whenever you are creating an object, here we are saying this is how if you make it, it's going to help you a lot. That is what the recommendation here is. So you might be wondering, I know how to create an object just by doing new on any class, I can create it. That's fine. But here we talk about how you can do it in a little different way. so that the nature of the object can be changed according to the nature of the program. So all that, this one will talk about mainly about how you can create different types of instances or different ways of creating instances so that it help you to make useful when you build bigger complex projects. So let's start with the first one, in factory method pattern. So what does factory method pattern talks about? Factory method pattern, or sometimes called as simply a factory pattern, it simply says that first of all, you define an interface or subclass for anything you want to create an object, and let the subclasses decide which class it has to instantiate. That means which class it want to create an object, let the subclass decide. You don't create an object at the forefront. That means it simply says that you just define an interface or your abstract class for whatever you want to create an object and let the subclass decide. You don't decide it. So that means it is the subclass responsibility to do that job rather than you. And this factory method pattern is sometimes called as a virtual constructor because it is really not doing anything for you. It is just lying out there, and whoever actually extends it or whoever implements that interface, they are the one who can actually go and create the objects according to their requirement. And if you look at factory method pattern, it allows your subclasses, that means whoever is implementing your interface, to choose the type of object they want to create. Like means if they want to create certain type of object, it's left to them. We are not saying anything. We will generalize it just by creating an interface. And it helps you to do loose coupling. That means it's not tightly coupled. That when I say tightly coupled, it is not like we are restricting to create a certain object based on only one data type. You're free to create your own data type, your objects with a different data type, whatever you want. So that's why these are sometimes called loosely coupled design pattern also. That means the overall responsibility goes with the subclass to do things according to it. Now, with respect to usage, what should we do? So we have an example program, but before that, with respect to usage, what actually you should do? If you look at it, first thing, whenever you want to create a factory design pattern, by the first thing you need to know is when you should use, if you look at it, when you should use when a class does not know what subclasses it has to create. That means it doesn't know like what is the subclass you can create, then it can just create an abstract or interface there. Or when a class wants the subclasses specify the object to be created, this is the second part of it. That means you're just creating the class, but you are not taking the responsibility of instantiating objects, and you are letting the subclasses decide when they want to create. And there are cases where you want the parent class take care of creating the objects of your subclasses. It's not you again. So if you look at this example, so here is the program we have, which is called factory pattern, and it has a class, and inside it is another static class. And here we have a person get emp string name comma gender, and whoever passes the name and gender. So first we will check whether the gender is equal to male. If at all it is male, if at all it is M, we call there's a class called male, which we have written here. This is the male class. And here, whenever the male is passed, it calls the male constructor, which is this, and it updates with its superclass, which is person here. And person superclass is nothing but it calls its constructor and it sets the name of the person. That is one thing it does. And if it is female, the same thing happens, just that we have a female class here. If you see, this is the female class, and it also calls it superclass, which is person, and the name gets set. And whenever it is getting set, automatically as soon as these objects gets created, when you create it, automatically it gets this greeting of, for the female it is Miss or Mrs, or for male it is Mr. Now if you observe, there is a one more abstract class. This is the abstract class we are talking about, where we are saying you just create an abstract class and let the subclass decide. So these are the guys who is deciding what they want to do, both male and female class, whereas this guy just gives you an interface with all the things need, like name, a constructor, it sets the name, and salutation, and get name and salutation. These are all abstract. And if you see these guys according to their requirement, in this case if you see, mail is setting overriding your get salutation method saying Mr, because mail you call it as Mr, right? Similarly, for get name and salutation, he is calling the get salutation of its own and just putting the name. Similarly, for female, it says get salutation. He is again overriding the method of person, which is our factory method, and he is giving, in the case of female, it's just returning the Miss or Mrs, whereas get name and solution, it just gives the same Miss or Mrs. and it gives you the name of the person. So if you see, this is the thing we are talking about when you want to create a factory design pattern. Here, if you see, he is not creating any objects. He is letting the others to do it. And this is the main program where you call it. You are creating employee factory.getEMP, which calls this, and this is where it decides which kind of objects to create. So you are letting these guys to take care rather than the main class which you have created where they can do it. That's what I said. Factory method pattern is more about you are letting the others to create objects based on their requirement. So here you are not doing anything. Here based on male, the male object gets created, female gets created. And if you see when this gets called, this particular based on the male, that male object gets created and you are just getting the get name and solution. Get name and salutation, if you see, it is already set as soon as the name is male, the skin gets called and it will call this get name and salutation, where by this time you will have Mr. and the name, which is Robin Hood here in this case. Similarly for female, when F code is passed, the gender when it is F, it creates the female object. So if you look at it, you have generalized the thing by not making it specific to male or female subclass, but letting it left to the subclass or the class who want to make use of it to take care of the responsibility of instantiating rather than you worrying about it. And if you look at, she also will get, Miss or Mrs. Then it will say Miss or Mrs. Mary. That is what the output should be. So the output looks like something like this. So the output will be something like, since you're calling get name and salutation, the output will be something like Mr. The first one, when you call Robin Hood, it will say Robin Hood. And for female, it will say Miss or Mrs. Mary. This is the output you're going to get. So here, the concept you need to understand here is you are not doing anything with respect to creating object. You are letting other guys to decide what they want to create, whether they want to create a male object or female object. You are not responsible in creating object anywhere. If you see, this is the place gets created and they created based on their logic. That's what the whole point of factory method pattern. Now, what is the advantage? Because you are not taking care of the object creation, entire taken care by the based on the logic you have written in employee factory. So it is, you're just delivering what is required. That's why it is called factory. You just deliver it. If you factory method, why the name is like in factory, what happens? They will supply all the goods to you. So based on your requirement, you stitch. I mean, so let's say the same kind of goods or same kind of clothes are sent to multiple vendors like A, B, C. Let's say they are the vendors. A might stitch in some other fashion, B might stitch the same cloth in some other fashion, and C might stitch in the same other fashion. It's up to them. But as a factory, you supplied what is required. That's all. That's why the name factory method pattern. And if you see, this is another example where let's say you have created a shape interface where you give all the required things and circle, square, rectangle based on their requirement they created for you. And whenever you want it, you will write a particular method from main, you will just call it. And if you want rectangle or if you want square, if you want circle, that particular objects get created and used rather than shape doing the job of it. Shape just supplies what it have without implementing anything, and he left everything to you so that you take care of it, and this gets created based on what is the customer is asking. Now coming to singleton design pattern. So singleton design pattern just says that define a class that has only one instance and provide a global point access to it, or provide global access to it. So what does it mean by that? That means once you define a class, you will make it such that it is accessible to everybody. So in other words, what you are saying actually is a class ensures that it has only one single instance created. Generally, if you see, whenever we create class, we are free to create as many instances of it. But here our thought process is don't do that way. Rather, you just create one instance of the class and that instance, let it be used by all the other classes it is required. That's what the main point. And in this, there could be two types of singleton design pattern can come. One is easy instantiation, another is lazy instantiation. In easy instantiation, the creation of instance happens at load time, whereas lazy instantiation, it is like ad hoc or on demand. So whenever you want it, you can create. Otherwise, it's not required kind of. Now, what is the advantage with this kind of singleton instance? If you look at it, saves memory because you're not creating object at each request. Generally, if you create a particular class called student, for every new student, you keep creating new objects, right? Here, that's not the thought process. Here simply says that we will create only one copy of the object and let it use the same copy for everybody. And why it saves memory, I hope you understand it. Even there are 100 students, you will have one instance. So it saves memory because not every object is not created for every request. One single instance is used again and again. And why singleton instance, where exactly used? If you look at it, is mostly used in applications where you do a lot of multi-threading, that means concurrent processing, or database applications where you want to do some kind of connection establishment and keep writing something to it or retrieving it. And also, if you look at it, best example is if you are aware of log4j and all. In that case, what happens is you just create one instance of your logger so that you keep writing, because your project might be containing hundreds of classes. You cannot create multiple loggers for each thing. Your thought process is for the entire project, everybody's the entire project, which consists of hundreds of classes, all this information, whatever the project is doing, should has to log to one file. Now, in that case, if you see, the ideal use case is you have to create just one instance of logger class. That way, what would happen is everybody able to write to the same file. If you create multiple instances, multiple files they have to write. So that is one area you can see this is highly used, and other things like caching, thread pools, and configurations. So now the question comes, how do you create a singleton design pattern? To create a singleton design pattern, what we need to do is we need to have just a static member of the class, a private constructor, and a static factory method. That's what we need. And so static member, why we need static member? Starting with, like I said, you need a static member. So why we need static member is because in static member, if you remember, static means it gets memory copy only once. For each instance, it will not create. For entire class, it will have one copy. That's why we said static member. Private constructor, so that we prevent to instantiate single instance class from outside the class. That means we are not letting anybody to create from outside. Private constructor, when we say, only the guys who is in part of the class can do something, not outside people. That way you are restricting nobody, you are restricting everybody not to create a instance of that particular class. Static factory, so this is like your global access point, where using that you actually return the instance. Rather than you create instance for every request, you are making one static factory where everybody has to call and do that. And that static instance factory is what you will do using this get instance method. Now, if you look at the code, this is the singleton sample code. So if you look at here, so this is the main one. If you look at in this main, observe this guy first, singleton sample.get instance. So each time when you call it, what really happens is, if you look in the entire class, the singleton sample is actually, this S instance is a static variable. This data is a normal one, and there is a private constructor. If you observe, this is a constructor, which is a private one. And who is creating a private constructor object of this? If you observe, this is where we are creating. And who is doing it? This is the guy who creates an instance for you. This is the get instance where we are talking about here. And this guy is creating instance for you. And he create instance only when it is null. So initially, first time it will be null. Once it creates an object, it won't be null. So this will create an object only one time. After that, whenever somebody calls the same get instance method, he will just return the same s underscore instance, which means the previous whatever object that is created, the same thing it will return. So here in this case, if you see, the constructor have one variable set, which is example program for singleton class, which is a private variable to it. Now what will happen? So first time you create singleton instance dot get instance. So what will happen is it will call this method and it will check whether it is equal to null. First time obviously it will be null. So this is the place it will create an object. That means first time. Now once it creates an object, this will return that object created. Now once this object is created, it gets stored in data1. Now second time when you call it, again this guy will gets called. This time it will not create because this time s instance is not equal to null. This time s underscore instance is equal to some value other than null. That means it has some object reference already. This object reference. So what it will do is when you call this time, it will return the same object instance to this guy as well. So that means what is happening for every request, this is your first request, first, second request. For every request, you are not creating multiple objects to it. You're just creating one object. And every time when somebody calls using this method, you are controlling and ensuring that only one copy is written. Now what happens once you written it, if you see here, here you are saying data1 dot data and you are casting data1 dot data and you are converting to uppercase. Similarly, so it will convert to uppercase whatever the string is. And what is your data1 dot data? If you look at data1 dot data is nothing but this guy. This is the variable because first time you created an object and data1 is here. Similarly, when you create data2 dot data, data2 dot data is also this example program for singleton class. So first time it will convert that example program from single class in all uppercase. Second time it convert example program for this particular string singleton class to lowercase. So each time the concept you have to understand is you are not creating multiple objects for every request. You're just keeping it one by controlling with a method called getInstance, which is static. And you will do it only when there is no object. Otherwise, you won't. That means only one time you do it, and after that, others will just reuse it. That's the whole point of singleton design pattern. The name why singleton has come is you're just creating one single instance of the entire class. Now, the same thing is explained. Like you see, we are getting all upper and we are getting all smaller. Now, the same thing is explained that whenever you first time you call it, that time single instance is set to null. That's why it is set to a different object, whatever it create. Next time when you call it, rather than single instance, since single instance is not null, what it does is it just returns whatever it has earlier. So that way, it is keep trying to keep just one single instance of your class rather than creating multiple instances for each creation of that particular class or each instance creation of that particular class. So if you see here, this is the main key. This guy is the one who is controlling it, and he is checking whether if I am null. If I am null, then only he is creating, which will happen first time. Otherwise, he just returns whatever the object reference he has. So obviously, first time whatever object reference he has, that's the same thing will written by second guy, and second guy will take care of it and just continue from there. So here the interesting point is when you are creating object, you are creating an object only when this instance is null. When your that particular instance, this particular single instance is not null, you will not create, you will just return the object reference. Now coming to builder pattern. So what does the builder pattern do? So what actually is a builder pattern if you look at? So builder pattern is actually, let's look at like this. It actually tells that if you want to construct a complex object from simple objects with a step-by-step process, the builder of pattern is the one. It is like an incremental pattern. Rather than doing everything, they say that, okay, take one step at a time and integrate all together to make a bigger one. Why it is used, if you look at it, is mostly used when your object can't be created in a single step, like in your deceleration of a complex object, it has to be done in step by step. That's where it is mostly used. And what is the advantage you get? It actually helps you to create a clear separation between your constructor and your object representation. And it supports you to change the internal representation of objects easily. And it provides better control in the entire construction process of that object. That is what the main benefit of this. Now, here is another example quoted in this particular slide. Like, let's say you're going to a restaurant and you want to go to dinner. Now, the question is, when I go to dinner with my friends, let's say, for example, I might not be liking the same kind of, starters or whatever they want. So, what we do, each of us either might order things which are commonly eaten by a lot of the people at that particular dining table, or either we prefer our own snacks or starters, and we say that, okay, this is what I want, let me get. So each have their own requirement, so according to their requirement they get their different things and they eat it. That's how it is. The builder pattern is exactly that. So you have something already existing from that. Rather than getting everything, it's like you build everything and keep it, but rather than getting everything, you take what you want and you build on top of it. That's all. So if you look at, like we talked about, it actually makes your object creation process simpler. That's what I mean by, control over construction process makes it's provide better control, and obviously better code format because you're not doing the main, the effort below it. Like everything is taken care and you can easily change the values. Like if you look at, so in this example, what we have done is so simple. It is like we have built a builder pattern. This is how our builder pattern looks like, where it is simply just creating just making a coffee with some of the recipes, like, what is the type of coffee he want, what is the sugar, what is the sugar, does he want sugar, does he want milk, and does he want something like the size in this case, it is like, the large coffee or small coffee, that particular size it means. So these are all the attributes it have. Now somebody might like a different type of coffee. Like in coffee there are different types, right? Mocha coffee or whatever other types of coffee are. And sugar, somebody need it, some might not. Some might need milk, some might not need milk. Some might need a large coffee or moderate coffee or smaller coffee. So all this. So if you look at in this particular, these are all the variables we have, which we are assigning it here. And here, if you observe, it's like the type is set based on what user passes, and sugar value also same thing based on what user passes, and milk also based on what user passes, and this is size is also based on user passes. And finally, this build will actually build and give you that coffee required. And when you print it, and this is the string format you are saying based on what you actually expecting. So here is the thing happens. So when you say new builder pattern dot coffee, which is nothing but you are creating an instance to it. So here you are saying in the coffee what and all you want. So first you said, I want a coffee type to be mocha. Let's say you can say other type of coffee, maybe cold coffee or some other type. So you said, I want a mocha coffee. That's the type you have said. And milk you want, you just set it to true. That means you want milk in that. And sugar you said false. That means you don't want sugar. And you said you want the size of the coffee is large. That means you want a large one. So what he is asking is in the type of ingredients, the kind of ingredients we have is for making a coffee, you have the different type of coffee, you have the sugar, you have milk, you have size of the coffee. Even though all these are there, based on the user requirement, you're just ensuring that what he want is what you give. Okay, so that's why it is called builder, because rather than doing one thing at a time, you have created the overall as one particular class, and you are giving flexibility to user to choose what he want by just creating an object. So what would be the output? You can guess. The output would be simply saying coffee. It will be something like this, coffee, and it will say type equal to, what is the type you have given? You have given type equal to mocha, and you will say that your SG1, you didn't ask for sugar. If you see, you said false. So it will say your sugar is false. That's what you asked for. Then it will say milk equal to, you asked for true. That means you are expecting milk. Okay. So this true will be set. Similarly, the size and all. So that is what you're going to give. Maybe if at all I change the type, in this case, if I change the type, I might get a different flavor of coffee altogether. So that's how what we have to understand here is, rather than building step by step, here you made a bigger thing. From that, you are incrementally building all the things required for a complex. So here you have to understand, when you want to make a coffee, rather than doing everything step by step, here you have constructed one particular single class that can do the all the job, and based on your flexibility you can change it. That's what I mean by builder pattern. You are incrementally step by step you are constructing what you need and making it happen. Now coming to structural patterns. First type we discussed about, uh, creational patterns. That means entirely about how to create an object kind of concept. Now we are going to talk about something called structural pattern. Here structural design patterns are more concerned towards, like, or more focused towards, I would say, rather than concerned, focused is the better word, where its focus is completely on how your classes and objects can be composed or contained so that it can form large structure. That is what the whole point of it. Okay. And this particular pattern helps in identifying the overall relationships between these objects and classes. And this particular focus area where you're saying we will focus on classes and objects, how they compose together to form larger structures, helps so that the classes which inherit from each other and how they are composed from each other, that actually will be very helpful. And in this there are 7 types of design patterns available under the structural patterns. And the structural pattern, these 7, if you look at it, it is like adapter pattern, bridge pattern, composite pattern, decorator pattern, facade, flyweight, and proxy pattern. So I'll just give you one liner of what each of them does. So adapter pattern tells you about how you adopt an interface into another according to client's requirement. That is what called adapter pattern. In bridge pattern, the second one, we say how you separate the abstraction. When I say abstraction, the interface from its implementation. In the case of composite pattern, you say how you can allow clients so that they operate on a hierarchy, object hierarchy. And whereas in decorator pattern, you add a functional to a particular object dynamically. So decorator pattern moreover looks like your generics, like based on the generics, if you see in Java, based on the type you pass, you can always write a generic where it can add 2 numbers or add 2 strings, where based on the type you pass, it will do the operation. It's more of that, not exactly, but it's more of that. And coming to facade pattern is about more about how you provide an interface to a set of interfaces. That's called facade pattern. And flyweight pattern is about how you reuse an object by sharing it. And proxy pattern, it is like how you represent another object. So these are the things. Now let's start with the first pattern, adapter pattern. Adapter pattern simply says that whatever the interfaces of class, just convert whatever the interfaces of a class into another class that client expects. You just convert based on the client requirement. That is the main theme here. That means like you actually provide the interface, like you have an interface, something like that, and based on once you take the client's expectations, you create an interface according to his requirement while using the same services of whatever class with a different interface. That's why it is sometimes called as wrapper also. Adapter pattern is also sometimes called as wrapper because of the same reason. And what is the advantage you get because of this? Now the advantage is it allows two or more previously incompatible objects to interact, because based on client requirement you are doing a lot there, and it allows reusability of existing functionality, because like I said, abstract adapter pattern is more about just convert the interface of a class into another interface that client expects. So what you're doing is you're not just throwing away whatever the interface you're having, you're just making use of it and making it in a reusable way by just converting it according to the client requirement. That's why helps in reusing the same thing rather than throwing the things out. That means here you're not jumping and creating a new one altogether. Now if you look at adapter pattern, the scenario will be something like this. So you have an interface movable where it gives you in kilometer per hour, where now comes for luxury car where he wants something in mph, which is like miles per hour. So what you do is this particular the same interface you use, but you change the speed of double to according to client requirement. It moreover follows this method overriding kind of concept here in order to let it go according to the client requirement. So if we look at this example, so this is how our interface looks like, where it has the movable object interface. In that there is display get speed, and that get speed function actually it is there as part of kilometer per hour. Let's say that's being the case. And if you look at this particular Rolls-Royce car, this is a luxury car. It implements your movable object, and it is overriding your get speed method with the 268 value. That means it is the miles per hour. Then let's say you want to return the speed in kilometer per hour. Now the same particular method from this mobile adapter interface, what you are doing is to convert the get speed, the same method. If you look at the same method, just for luxury car, you have just overwritten it, the same method. Whereas for other implementation, what you have done is the same get method. Inside you have written a convert mile per hour to kilometer, and it is just converting it and giving it back for this luxury car. So if you see, we are not changing our interface. We are changing our interface in such a way that according to client requirement. One time it could be miles per hour, another time it could be kilometers per hour. So you can see that this is how when we this is the test class where we are showing how to create this, where first time you create a Rolls-Royce car. So user knew that okay, he wants something in, you know, what to say, kilometer per hour. We are not calling it actually here, we are going to get in miles per hour, by the way. So but actually it is the requirement is like first time you create based on, whereas next time according to the client requirement you converted the same, you use the same interface and converted it according to the client requirement. That's the whole point of it. And here in the test class what we are doing finally is, here we are actually checking whether the get speed whatever it is returning is it equal to this value or not. That is what we are checking asset. This is more of a test case. If you remember, we learned about test ng or unit JUnit, and this is what we are saying, this is the unit test you are testing to see whether it is really converted that miles per hour to kilometer per hour or not. So if you remember, we are just checking is this properly done, and when it is done the get speed value is it equal to this one. That's what we are checking here. So there is another example for the same uh, pattern, the adapter pattern. So here if you see, there is an advanced media player and there is VLC player, MP4 player. So here if you observe the same advanced media player, whatever it is given, maybe the VLC player might need this play VLC, play MP4, but they might have overridden there according to the requirement, similarly for MP4 player. So you're just using the same interface for these two classes separately. That's what being shown here. So how you are implementing and all that. And in main, you just make call so that you get whatever particular player according to your requirement. Now coming to bridge pattern. So if you look at bridge pattern, what does bridge pattern says it? Just you decouple the functional abstraction from the implementation. That means, what does it mean is, here generally when you write code, that's called implementation. And when you say abstraction, functional abstraction, it just means that whoever want to use just know to know my method name and the method parameters. That is called functional abstraction. They don't need to know about your implementation inside. That is something you can call it as black box testing also. Black box testing also same, where you say that you don't need to worry about how things work internally. You just need to worry about this is the input and this is what the output you're going to get. So functional abstraction is exactly that. So what bridge pattern says that is, just whatever you want to do, just decouple. That means just you separate out both your functional abstraction from the implementation so that they work independently or they can change independently. Because of this reason, it is also sometimes called as handle or body. And what is the advantage with this? The advantage is it helps in separating your implementation from the interface. So when your implementation is separated from interface, the biggest advantage you get is you can easily extend the code. Because I'll give you one example. Like I was working on a project where the project is something like this. The project, in order to use my application, user have to set up some infrastructure. Now, once he set up infrastructure, what he want to do is he can, there is two parts here. There's one is infrastructure part and another is application part. Now, I haven't combined them both. I have separated them together. Like both are two packages. Now, the advantage with for me is infrastructure setup part, which is a package which does the job of all infrastructure startup in the AWS. I'm working on AWS side, by the way. When you do that, this particular infrastructure setup itself needs a code because you are setting something on the cloud. Now that infrastructure I have written separately, the advantage I get is anything on the infrastructure I can change easily. It is not related to your application, by the way. And my application, it is just that infrastructure just puts wherever my application want. The infrastructure main job is put application, whichever infrastructure I said, it's going to put that my application into that infrastructure. That's what infrastructure does. Let's say initially I have said infrastructure package to put my application in Lambda. Tomorrow I can say the same package you put in EC2. Tomorrow I can say the same package you put in ECS. It is immaterial. Why? I didn't put both the codes in one place. If I put both the codes in one place, it is very difficult. So I made that abstraction clearly saying the implementation part, which is the actual application, I decoupled from the infrastructure part, so that the infrastructure, once it's set up, it doesn't know anything about application, and application doesn't know anything about infrastructure. It just deploys wherever it is. Okay, now coming to the what is the advantage I get is my application, whenever I want to extend any feature, I don't need to care about infrastructure at all, because it's an infrastructure job that where actually it takes care of everything on setting up my infrastructure. Today it is Lambda, AWS Lambda. Tomorrow it could be EC2. Tomorrow it could be, maybe later it could be ECS. Later it could be something else. I don't know. But as of today, I don't need to worry about where my application runs. I can simply go and extend my features altogether. And if at all I want to change the infrastructure tomorrow, I just touch the code. I'll not need to worry about how my application behaves, because my application behaves immaterial to that. So that is a best example of bridge pattern, where you are completely separating out your application part with your infrastructure setup. So here in this case, the functional abstraction is, your infrastructure, and the implementation aspect is your application. So the same thing, it helps in extending. Like I said, my application can easily extend because it doesn't need to worry about the interface. And it is easy to hide entire infrastructure, because hide entire application, because when I give to my customers to use my tool or application, all I give them is infrastructure. They don't even know where is my application at all. They just think that, okay, there is one package this particular infrastructure deploys, and that package have all the details, and they don't need to worry about it. They just set up the main package which does the main job of setting up all the infrastructure so that application runs. So here, the biggest advantage, you do not have any binding between your function and its implementation, because both are separated. Here, the function and abstract function is nothing but your infrastructure, like I gave an example, and implementation is your actual application code. And how it helps, you can easily extend your implementation to add more and more features. That's what it meant by extending using subclasses. And at any place you want to use, your application can easily extend. That's what it talks here, that whenever you want the changes in the implementation, it doesn't affect the clients, because my client looks at just the infrastructure package. So wherever I want, I can change it completely. So this is a high level of how it works. You provide an abstraction for your implementation where you don't implement it, and you actually provide the concrete implementations here, actually the implementation part. But if you see that this is an abstract part where you don't do anything and let others take care of it. So your implementation as well as the function abstraction part of it is clearly separated out. So if you see here, this is an example where create API is the interface and round circle is one of the functional. Now, this function, I don't care how this round circle is implemented by whoever implementing this. So this is my functional abstraction. I just give them a function name and the parameters. That's all. And it's the responsibility of these guys, like in this case, pink round circle, or these guys to implement according to their requirement. Like for example, if you see pink round circle, they are implementing the round circle method here. That means my function, which is abstracted here without writing any code, they are implementing the code by writing the code according to their requirement. Now, if you see the same pace, this guy also implementing according to their requirement. So implementation is immaterial. Tomorrow, if this guy want to extend, he can freely extend. For him, doesn't matter. And at the same time, tomorrow I want to add few more functional abstraction method, I can easily add. And whoever want to add it, whoever want to use it, they can add it. So adding new more functional abstraction like this method is like adding few more features to it. Okay, like in this case, now I provided one API, tomorrow I want to provide two, three, I'll just add it here. That's all. And whoever want to add it, they can just use that API method name and implement there according to their requirement. Now, if you see, this is how your design will look like, where in that you said, okay, this is how I want to use the shape. Yeah, this is the shape is the, you here you are creating it, then you are making the create function. Now where here you are creating an abstract, this particular thing where you have created all this create API, which we have created there. So the create API is this one. The same thing on top of it, you have created an abstract class saying design, and whichever shape you want, you can design based on the values you pass here. Now, if you see here, in this, you are saying this is round circle, you are creating your own circle interface. If it is pink circle, you will create your own thing. Now, this is where if it is pink circle, if you see you are creating a circle, pink round circle, and in this case, it is a different circle, blue round circle. So you are passing different implementations of it, where whenever you call it, when you pass pink round circle, this implementation will get triggered. When you pass blue circle, this implementation will get triggered. That means that object's code or implementation will come into picture. And as you can see, based on that particular object you have passed here, it automatically invokes that particular implementation of the code, which is pink round circle and blue round circle classes we have written. Now coming to facade pattern. So what is facade pattern? So facade pattern actually says that you just provide a simple and unified interface to a set of interfaces in a subsystem, and thereby it helps to hide the complexity of subsystem from the client. So what does it mean is, it just simply says that you create a high level interface so that your subsystems or the guys who actually take that interface can make the subsystems takes the subsystem, can be it is easier for them. That means you just describe a high level interface that makes the subsystem easier to use your interface. That's all. So it is like a higher interface, then from there you can get a set of sub interfaces again. Practically, if you look at, every abstract factory is a type of facade. Okay, and the advantage you get here is it actually helps the client to shield the complexity or hide the complexity of your subsystem components. You don't need to worry about it, and it also promotes loose coupling between your clients and systems subsystems. And what is the usage of facade pattern? So you will use facade pattern when you want to provide simple interface to a complex subsystem, because what we say is we will just give a high level interface and let the subclasses take it according to their need. And one more advantage is when several dependencies exist between client and implementation classes of an abstraction, this is very, very helpful. Okay, so you see that. So like I said, we just provide a high level interface that makes the subsystem easier to use. Like I said, it's a type of abstract factory, and where it helps when you want your end users, it protects your end users from the clumsy subsystem. The reason is because you're just providing one single interface to them rather than providing multiple interfaces of your subsystem. And since you are hiding a lot of complexity, it actually helps you to use a simpler interface rather than the complicated system inside. And problem, if you look at use cases, multiple use cases are there. One use case would be like what is mentioning here. A segment of client community needs a simple interface to the overall function of the complex subsystem. That means in this facade pattern, what we do is whenever you're given a problem, let's say there's a, so let's take an example, like let's say electricity bill. In the electricity bill, if you look at, there are different types of electricity bill can come in. Like you have one super interface which talks about the electricity bill rate. But apart from that, based on different customers, like customer types, like it could be, you know, the domestic customer, like every household, or it could be a business customer, or it could be an enterprise customer. For each of them, the billing and unit is same, right? So for this complex subsystem, which is the high level billing interface, you just write one and let these sub interfaces like domestic, uh, this guy, enterprise, business, they'll act like sub interfaces to it. And from there, whichever interface you want, user will just use the simple interface where they will call and get the thing done. So that's how you can make use of this packet interface, where it helps you to hide the complexity. Because if you just take the billing interface and try to implement everything there, what really happens is you will get a massive, code need to be done, where you have to take care of how it has to happen for domestic, how it has to happen for this business, how it has to happen for household, all that. It becomes very difficult for you. Whereas when you make a big interface, a high level interface, and create sub interfaces for each of it, and on top of it you just make a simple interface where based on particular customer type you invoke it, it makes your job even more simpler. And that's the whole point of facade pattern is. And that's why this is being called as one of the abstract factory, because you're just giving one of the high level interface to it and let the sub interfaces, let the subclasses use their according to their own requirement. Like this is, you can call it as singleton also, because you're just using one type of object every time. What we do is, these are all actually called as wrappers also sometimes, because what you're doing in the facade pattern is you're just creating singleton. So if you remember, singletons is nothing but you just create one instance based on the customer requirement. Like in the electricity bill example I have said, based on the customer type, I might create one instance of domestic uh, customer object, or I might create one instance of business customer object, or I might create one instance of enterprise customer object, and I will just use it for different customers. That way it can be look like a singleton pattern also. So if you see here, here we have simple example. Like one simple example here is, you have a Cartesian product class, and it has certain constructor where it takes two value and it will have methods like move one. Similarly, you have polar point, and it has its own method where it takes radian and angle and do something. And similarly, you have, if you look at here, you have a point, that is another class where it has something called a constructor which sets up some point Cartesian and all. And finally, if you look at it, it has some data, some method here. And here is where, if you want to draw a line, if you observe, this point class is coming from here. That means, given that this particular first one, second one, and third one, you have three high level subsystem. From there is a five level systems. From there is a subsystem forming based on using them. Like here, if you see, the point is formed based on the point, the line is getting created, and this point is nothing but this class. This is the class from which they are forming one more subclass based on the user requirement. Now, when I want to create a line, if you see here, I'm not just invoking the line. Here I'm invoking the other aspects also, like point, which is nothing but this class. That means you are forming a subclass based on a high level interface, which are these three given. Now, this is another example. Like if you see, there is a shape is the interface. And again, shape might be this draw function might be required for circle, rectangle, square. So they will implement according to their use case. But again, some of the things might be reused here. So that's what the whole point of facade pattern here. And when you write it, like you can see, all of them are part of the same shape class, circle, rectangle, square, right? They're all part of the same class, just that they will have a different functionality, which some of them might use it again. This guy might be using this. In turn, this guy might be using some functionality of, square. If it is using for lines, it might be using some functionality of rectangle. It could happen anyway, right? So that's what the whole facade pattern is about. So facade pattern mostly talks about how you build a complex subsystem by getting it from small step-by-step system. That's what called facade sub pattern. Now coming to flyway design pattern. So flyweight design pattern says that you just reuse already existing objects by storing them and create new object when no match object is found. That means what it says is whenever somebody asks you to create an instance, look if there is a similar kind of object exists. If not, then only create it. Otherwise, don't do it. Just reuse it. That's what the whole point of it. And you might be thinking, what kind of use case is this? I mean, this is really required and all. There are certain use cases, if you really look at, where you don't need to end up creating objects again and again. You just can reuse. That is the place where it is really helpful because the is if you really look at, where you don't need to end up creating objects again and again. You just can reuse. That is the place where it is really helpful because the main advantages comes there where you are not unnecessarily creating objects for everything, only creating when it does not exist the kind of object you are expecting. That means you are reducing number of objects. When I am saying you are reducing number of objects, it simply means that you are reducing the memory required, because each object, as you know, it occupies certain amount of memory, and that's what you are reducing. So when you say reduction in objects, number of objects, obviously it reduces the amount of memory and storage required, because the more objects you create, the more storage required, and the more memory allocation and deallocation has to happen. All that you are reducing. So performance wise, if you look at this, flyweight design pattern really works very well wherever you need performance. And where you use the flyweight pattern, if you really look at whichever application, whenever you think application uses large number of objects, maybe you can look at this guy to see using this design pattern can I optimize it. And the other use cases could be like, let's say, like I said, the overall point of overall why we want to do it is to optimize your memory. That means like whenever you want to make the storage cost, we reduce the storage cost, which is higher now because a lot of objects are getting created. And other use cases could be where your application doesn't depend on the object quantity. That means your application shouldn't talk about only when there are 30 objects I can work, or only when there are 40 objects that doesn't work. Those are the use cases it really fits well. And your motif GUI, if you look at that, uses the strategy of same thing. Okay, so for example, if you look at, this is one problem: designing objects down to levels of system granularity, providing optimal flexibility, but it can be expensive in terms of performance and usage. So what does it mean is like you want to design a particular system to more granular level, but when you are saying granular level, always remember that the more granular you get, the more uh, cost will be required in terms of both performance. When I say performance, execution speed, as well as memory, because you end up creating a lot of objects to get more granular information. So how flyweight pattern can be used there is, what you can do is to avoid the cost, you can make the entire flyweight object into two parts. One is state dependent, another is state independent. State dependent is something called extrinsic, and state independent is something called intrinsic. And intrinsic part or intrinsic state is where you store your flyweight objects, and extrinsic state or your state dependent state is where you store your compute part of the client objects. And only when you want to you will pass to the flyweight object only when you want to invoke certain operations. So that is how you can design it. This is one just kind of approach. Okay. Now, what are the real world use cases if you look at where it can really helpful is the real estate management, or wherever you want event driven programming and all, there this flyweight design pattern really shines well. And this is how it looks like, where you have a factory of this particular make flyweight and this flyweight. So if you see, this is the shareable state, which is the intrinsic one, and this is the extrinsic one where you are calling the operations of it, and your client will just make a call to the required one. And here you don't need a lot of objects and all. There are cases where even though you say flyweight is mostly for reusing the objects, because you look at whether similar kind of objects exist by storing them and just reuse, or you will create only when that is not required. Sometimes it end up creating a lot of objects, because when I say you look up whether similar kind of objects, you have to store it. So that kind of problem can actually be can actually be resolved by sometimes combining with facade design patterns also. So the whole point is like you can integrate, you can combine some of these design patterns where and when, based on how you want to make use of it. So if you look at here, this is a very simple example where it talks about here this is the actual pattern we are talking about, where you created a class with just max per row, and this is the constructor where whatever based on the value you give, you create the number of rows, number of columns, and just increment the number. And this is where you do the flyweight test, where you are creating a matrix of Gazelle, which is this by the number of rows and columns, which is 6 and 10 here. And what you are doing here is each time whenever you're traversing through this rows and columns, you are creating this gazelle of columns. So here gazelle of columns is nothing but for each invocation, that means first time 0 0, it will create 10. 10 times it will create, it will actually pass the 10 value here from here first time for a 0 0 value. So again when 0 1 comes, it will again call this constructor one more time. Like that it keeps calling that constructor again and again. That means understand that when you're calling constructor, what you are doing is you are actually creating objects. That means for 0 0 there is one object created, for 0 1 there is another object created, for 0 2 there is another object created. Like that it keeps creating multiple objects. Now once it is created, like I said, whenever you want it, we will just make reuse of the existing one. Only when it is not there, that's where you create it. So this is where the reuse part comes, where if you see we are just calling matrix of I comma j, I is j dot report, where you're not creating an instance to call this report method. What you are doing is you're just making a call of this function matrix of matrix square bracket I of j, which is nothing but one instance of this gazelle of rows which you have created, and using that you are making call to this report. Now when you call it, what really happens is, since you call this every time based on which particular object, when you pass 0 0, since these objects are already stored, it refers to this first object. And when you make call to 0 1 in this loop, it will refer to this object. When you make call to 0 2, it will refer to this object. Like that every time it keeps referring to the objects persisted and reuse them rather than creating a new one. That's what the whole point. But if you see here, one biggest con is sometimes when you go too much granular, it might end up storing too many objects also. So that is where you might need to think about how to integrate with the other design patterns you have so that you make it more better even. So this is what I was saying. So each time, whatever it has created is what it is showing up here for 0, 0, 1, 0, all that. So let's discuss about behavioral design patterns. So what exactly is behavioral design patterns? So behavioral design patterns, if you look at, it's more about how you ensure there is some kind of, I mean, the focus is more on the interaction and the object's responsibility. That's what the entire focus of these design patterns are. In these design patterns, the interactions of the objects is actually built in such a way that they can easily communicate with them, and still they are loosely coupled. That means the communication of the objects will happen, but they are again loosely coupled, and which means the implementation and the client side implementation are loosely coupled in order to have the hard code, avoid these kind of hard coding and dependencies. Because generally what happens is both the implementation and the client side implementation, you are coupled it so much that separating it out uh, will cause a lot of issues later. Whereas here we ensure that the implementation part and the client side, whatever the implementation required, is loosely coupled so that it avoids a lot of hard coding and dependency issues. And here, if you look at, we have 12 types of behavioral design patterns, and they are the chain of responsibility pattern, command pattern, interpreter pattern, iterator pattern, mediator pattern, memento pattern, observer pattern, state pattern, strategy pattern, template pattern, visitor pattern, and null object pattern. If you remember, like we discussed in the entire design pattern related to core Java, there are three types. One is the creational pattern, structural pattern, and this is behavioral design. In all these three, this is the design pattern structure which have more types of variety of design patterns possible. So let's look at the strategy design pattern. So what does strategy design pattern says? Strategy design pattern says that you actually define a family of functionality, encapsulate each one, and make them interchangeable. So what does it mean by encapsulate, make them interchangeable and all? So here, if you look at in the strategy design pattern, it is like, more of inheritance kind of thing, what a substitution to subclassing. So what in subclassing you do? when you create a subclass, what you do, you reuse the behavior of your parent classes. That's what you do. So it is more of that substitution pattern where, let's say you have defined certain kind of operations in your superclass, you are reusing it. Instead of that one, you can use it. This pattern can be used as a replacement. Where what this guide says is you first define whatever functionality you want, encapsulate it, and you ensure whenever you want, you can automatically change it. So one simple example to implement this, which actually help you to more understand it more clear is, let's say I want to implement, addition, subtraction, multiplication. Okay. And here there will be one method called calculate. So actual your interface, which is given to user, will have only one method called calculate. This is an abstract method. And based on user, it will, based on whatever user request, you will trigger whether it should be, the calculation should be addition or multiplication or subtraction. So this calculation receives two parameters, a and b, and based on the user requirement, we will trigger this. Now how to do this, we will create a context factory, less like the earlier case, earlier design pattern, where you actually get the context, like whether you want to trigger. So the here also, if you look at, there is a context factory. It is more of a state specific behavior, it looks like, right, if you observe. So in this context factory is where you set what do you want to do, whether it is addition or subtraction or calculation. You just set the context, that's it. You will not invoke it. Where after setting it, whenever the invocation part comes here, where you just say calculate. So in the earlier case, you set the context and automatically the relevant one will invoke. Here it is like you set it, then there is a later another interface where you call calculate. Since the context is already set, it automatically knows that it has to do addition, multiplication, subtraction. So like that it understand. So here, if you look at where is the strategy is, the strategy is in setting this context, and after that, if you just do it, calculate, it automatically understand it. So if you look at your all your core Java APIs, the JV package is implementing this strategy pattern. Your J2E, in J2E, there is something called JavaX package. All that is implementing this particular thing. And when you actually use it, if you look at is the usage of this comes when you have multiple classes differ only in their behaviors. Example, your servlet APIs. Or you can use this when you need different variations of an algorithm, because the same algorithm, different variations of an algorithm, when I say that rather than addition, multiplication, subtraction, you can write algorithm one. Maybe if you take a searching an element in a list of elements, that you can write multiple approaches, right? Maybe that is one version. The same searching element, you can write another version. The same searching, you can write another algorithm version. So this also you can trigger using this strategy design pattern. And the advantages, obviously, it is a substitution of your subclassing, the inheritance part. And here, one more advantage you get is you define behavior in its own class, eliminating the need for conditional statement. Because if you see here, we are not putting any if condition to say that if the customer is from account department, if the customer needs addition operation, if the customer needs multiplication operation, if the customer needs subtraction, we are not doing anything of that sort. We're just taking input from the user and setting the context. That's it. And after that, it's getting done. So it is avoiding all the if conditions and all for you. And since it is that case, it is actually helping you to extend easily and change the new behavior without changing the implementation at all. Now, this is another picture where you see that, there is a city bus, personal car, and taxi. So based on where to transport, where to transport is your context. Transportation to airport can happen either of these three. And how the transport has to happen, the strategy is set already here. So based on what do actually you want to transport, based on that context, you set strategy, whether it has to go through city bus or personal car or taxi. Let's say if it is a close relative, I might be sending through personal car. Let's say if it is some known people, I might be sending a taxi, and if there are a lot of people, I'm going to be sending through city bus. It all depends based on the state. And template we haven't discussed, but the strategy design is like template method except in its granularity, because template talks more on the granularity part as well. We'll look at it in a while. Let's start with chain of responsibility pattern. So what does actually chain of responsibility pattern does? So in chain of responsibility pattern, sender sends a request to a set of sender sends a request to a chain of objects. and the request can be handled by any object in the chain. That means given you have a bunch of objects in a particular chain, when a request is sent, it can be handled by anybody. That's what it overall means. So now you can assume something like this. Like let's say you have a multi-server, like you have 100 servers. Let's say, for example, a Google server, a Google search, and Google search behind there will be multiple servers sitting. And whenever you search something, the request can go to any of the server at the Google end where it can take your request and process it. It is more about the chain of responsibility pattern kind of thing. Now, what is the advantage you're going to get with this kind of structure? So the advantage, the bigger advantage is it reduces the coupling. That means there is no deep coupling involved. It adds flexibility so that you can assign responsibilities to objects, and it allows a set of classes to act as one. Like rather than being act as independent, now it acts as one together so that all or any one of them can handle it. Now, where exactly you use this kind of chain responsibility pattern? We already discussed like client server architecture. That is how the chain of responsibility pattern comes. Other than that, you can assume scenarios where whenever you need more than one object to handle a request and the handler is unknown, that's the case you can see chain of responsibility pattern is useful. Other than that, whenever a group of objects that can be that can, let's say if there is a group of objects that can handle that can handle a request, if that can be specified in a dynamic way, that's also another scenario where you can do it. And the best example which we do every other time but we don't realize is your logger. So whenever you do using logging log4j, right, if you really want to build it, you can build it using this chain of responsibility model where you just build a particular logger, and that's been shared by multiple guys. Like if you see here, like a logger with multiple classes, like where you have each class, one class of logger takes care of, let's say, the one logger class you have for taking care of error, another logger class you have for taking care of warning, another logger class for taking of debug. Now, based on whatever object request is, you can trigger that particular error or warning or debug. So that is another example you can think about, like using was built using this chain of responsibility model. Another could be your multi-server processing request. That is another thing which we already discussed. Like you can see, when the request is passed, it can be handled by any of these processing element classes, and one of them could handle it. It could be any one of them, either it could be this or this or this or this. And whenever somebody is not able to handle, as per the chain of responsibility model, it passes its work to the other guy. Now, this is another example, the ATM machine, which you already spoke about. Like, you know, whenever you put come card, you get it. And the request at the backend can go to any of the servers sitting. And that server will authenticate your request based on your PIN number and all, validates it and sends back whether it's a proper customer or not. Based on that, you get the required money. So here, if you look at in the chain of responsive model, you have some command, mediator, and observer. How do you decouple this sender and receiver? Based on that, we actually distinguish saying, I mean, what is the we actually come up with these rules where we say that you should have one commander class, one mediator, and another observer class. And here, the main point of the chain of responsive model is you will consider your request as an object here. Now, coming to command design pattern, the chain of design pattern, if you say, that get talks about when you get a request, it can be processed by any of the objects, and if it is not able to do, it will pass the responsibility. That is the overall principle of it. Similarly, the command design pattern, what it says is, like, it will encapsulate your request under an object as a command and pass it to invoke the object. Invoking object, just like it looks like more of appropriate object which can handle this command and pass the command to the corresponding object, and that object it executes the command. So it is more about, like, till now when you invoke an object, you invoke a particular operations inside it. Now what we are saying is, rather than directly invoking the object operations in that object, you invoke the object as a command. That means the object itself is a command. So based on that command, that relevant object will automatically come in and process your request. So that's why it is also known as action or transaction sometimes. And what is the advantage with this approach? If we see, the biggest advantage is it separates your object that invokes the operation from the object that actually performs the operation. Like I said, if you really write a class and create an object, you will write all the operations in that class itself. That means The operations as well as the invocation of that operation is both tightly coupled. Whereas in this case, what we are saying is the command will be something else and the invocation will be separated. That means when you invoke, the invoking class does not have any information about how that operation will happen, where the operation is completely separated about. Okay, and based on what command you pass, the relevant object will be triggered. So here, if you see, the invocation as well as the implementation of that command is separated out. And with this, what is the biggest advantage you get? It helps you to add easily new commands because existing class remains unchanged because your invocation class always remains the same, whereas new command comes in and those are being added. So extensibility is very high here. And if you look at where exactly we use this, whenever you want to parameterize objects according to an action plan, that means you have some actions to perform based on that you want to parameterize, this is very useful. Or whenever you want to create and execute requests at different times. Or let's say you want to support some rollback, logging, or transaction functionality, this is the one you should look at. And with respect to, this is one scenario we are being given where we talks about, let's say if you want to issue request to objects without knowing about the operation being requested or the receiver of the request, then this is the guy. Because here, if you see, we are treating the execute part of it or the operation part of it separately from the invocation part of it. And the invocation part of it, it need not be aware of what is the execution part of it also. Now, here, if you look at the entire, the command design pattern, if you look at either these rules and all, so basically when you want to construct a command design pattern, what are the things you need? So before that, let's talk about a particular example. Let's say, for example, you want to create a notepad file where you want to just give operations like an editor and saving and opening file. Now, if you want to build it as class using this command design pattern, what you can do is you can design one class for saving file, another class for opening file. So now you have two classes, one for saving and one for opening the file. Whereas you will build one more class which just says execute as a method inside it, just execute. Now this execute method, what it will do is, like you have one, like I said, one for saving, this is one class, and you have one for opening file, that is another class. Now the execute class is the invoker or the invocation class. So this particular execute, the other class which I am talking about, this is just an invoker where it has a method called execute, and this is the method in actually your program where you write main method where you pass saying whether I want to you make use of save or open. That is what you're going to mention here. And here, these guys are your commands. So here, if you see the invocation is this guy, which is in one class. This is, let's say, third class. And your actual class, the commands, the save is in one class and your opening file is in another class. So all these are separated. That means the actual operation, which is this save and open, as well as the invocation of them, which is this execute, are separated completely. Now the advantages, like I called out, like you can easily extend the commands because there is no tight coupling here, and you can always extend your functionality of invocation also because that is also not coupled. So that's being the overall point of this command design pattern. And if you want to build this command design pattern, the basic entities or things which are required is, one, you need the command where actually the interface for executing an operation. So these are the commands here. Another is the concrete command, which extends this class. Actually, this command, ideally, when we build it as an interface. And this one we will implement using some concrete classes. And in that, we will write methods. And after that, we write a invoker as well as receiver. So those are all things are required. Now coming to interpreter design pattern. So what does the rule of interpreter design pattern says? This is mainly to give you an idea. This is mainly used for all this syntax, grammars and all when people build programming language, right? That's where this is heavily used. Why? Because this interpreter pattern says if you want to represent a grammar of a given language along with an interpreter that uses the representation to interpret sentences in the language, then this is the design pattern you can look at. Because if you look at the interpreter patterns are limited, they are not like heavily extended. They are like, if you look at every time where a program language gives an error, it says that syntax error and you are supposed to use a limited set of syntactical notations, right? So that's why it is saying it is a limited where you can apply it. And you can discuss interpreters only in terms of some formal language or formal grammar. So formal is like nothing but it's not a spoken language or something. It is another language or a meta language put on the to represent something kind of. And this pattern you can apply for parsing your expressions if you define in simple grammars and sometimes simple rule engines also. And by the way, most of the languages which uses some kind of parsing to identify whether your code is whether your commands are giving errors or not uses this interpreted design pattern. Just to give you another real-time example, your SQL parser, whenever you write an SQL command like select star from some table name, that SQL parser is actually written using this interpreted design pattern. And what is the advantages? This advantage, it's mostly like it is a limited functionality of this particular interpreted design pattern, where it is easier to change and extend the grammar using this design pattern if you build it, and implementing the grammar is straightforward. Why? Because you have just a grammar parser where you write it how to do it, and you have a interface on how to convert it. That's all. When you use this particular thing with respect to usage, if you look at when the grammar of language is not complicated, because we are talking about a limited set here, and efficiency is not a priority because where 10 times you parse it, there is a high possibility that your efficiency comes with a toss. One example could be if you look at, let's say you're building an interface where the interface just talks about infix to postfix. So infix to postfix is like you give an expression. Now when you want to build this kind of thing using interpreted design pattern, what you can do first is, first you can build something like you can build an interface with just a conversion method, and then you can build a class where that class have the infix to postfix functionality. Then once that is done, in main method you just write the code where you just make call of this infix to postfix, simple one, that's all. So like I was showing, like this is another example where if you want to play a music, here you have two classes, notes and signature, and whichever you wanted, you just create an object and you make use of it. That's what it is trying to show here. And rules, I mean, there are certain rules, like for example, one, if you look at it in a general way, interpreter pattern, you should reserve only for the cases where the class hierarchy is defined as a language. This is very important. And it can use state to define parsing context. And the abstract syntax of this interpreter is composite. That is another thing you need to remember. And this is mostly one more thing. This is mostly useful when the grammar is not as complex. That is what being mentioned here. If the grammar is heavily complex, then you have to use for other techniques. When the grammar is fine, when the grammar is not heavily complex and it is limited in even limited character set, then you can go for this particular interpreter design architecture. Now coming to iterated design pattern. So if you look at iterated design pattern, so iterated design pattern is heavily used if you ever work with, your enhanced for loop in Java, or your for loop in Python, or your collections also in Java, you have for each. All this use this technique of iterated design patterns. So what is this iterated design pattern basically? So iterated design pattern simply says that you access the element of an object or any given object without actually exposing or without showing up how the internal implementation works. That means you will not show the interpreter internal implementation, where you just say that okay, you do that and it will work. So for example, if you write in Java for each, how you write it, like you will write something like this, right? You say for each, you will write something like this, where first you give a data type int, and you say I colon, let's say this is an array, this a array simply, and you start writing system.out.println and you say I. Here you do you know like how the elements here, you are not specifying from which location it has to fetch an element. You are not specifying how to increment from each location to another. You're not specifying how the increment has to happen. Is it has to happen one element at a time, it has to pick, or two element at a time? You're not specifying, automatically it picked up. So that is what meant by internal implementation is hidden out here, and you just give the purpose of how to access it. That's all. So that is called iterated design pattern. So as you can see, most of the C++ and Java standard library abstraction, it actually made it possible because of the structure. If you want to give an example with respect to your own language, your java.util.iterator, which is the interface used by your for each and this collections for loop, are actually implemented using this iterated design pattern. And sometimes this iterated pattern is also known as cursor, because if you see, it compares with the SQL cursor. If you remember, similar to that, Here also it helps you to retrieve the elements from any data structure one by one, or you can say any collection. And what is the advantages with this kind of approach? It supports variation, it supports variety in your application collection navigation, whichever you want, you can get it. And it simplifies the interface. Like I said, for loop, you don't need to worry about initial value. You don't need to worry about how to increment the value. You don't need to worry about how it works. All that is abstracted. That is the best part of here. And when we should use it? Whenever you want to access a collection of objects without exposing or without showing the internal representation, then you can go for that. Or when you want to traverse multiple objects you want to support in a collection, you can always build this particular thing. That's the best part of this iterated design pattern. So iterated, like the name says, this is actually comes under your generic programming concepts. So like it is mentioned here, generic programming is more about you explicitly, I mean, you will not tell algorithm saying, okay, this is the data I'm going to pass, you have to iterate like this. If you ever worked on the for each in your collection, if you see the same for each, you can write in a way so that you pass any data type, so based on that it can automatically traverse through all of its element. So it's nothing but generics programming where you are not telling it what kind of data you're going to pass. Based on the data you can automatically iterate through it. Okay, so that's the best part of this particular iterated design pattern. So since this pattern is available, there are multiple opportunities we get to implement multiple things, like why we are having for loop without having initial value increment. That is another example. And not only that, you can build your own iterators using Java collections so that you can come up with more structures like this. Like you can see here, this is just a general example where it says about, okay, there is this channel iterator, which is the iterator, and it's the purpose of the channel selector. So whatever the channel you select, it automatically gets you that channel. So there is a next, and whenever you implement an iterator, always you need to implement two basic methods at least. One is the next method, another is the iterator object method, and sometimes the previous one also. But these two are mandate where need to be implemented, where iterator says that this is the iteration object I have to create it. Next is every time it gets the next element for you. These two are very important. So once you implement this in iterator, it is all about a channel selector like that in a TV, where they just select the channel and it automatically gets you the next channel or whatever. Since it is TV, you want the previous channel. That's why we have written the previous channel as well. So here, if you see the channel selector, or here in this case, the remote controller which you use is not aware of how this works. It just press the keys and everything works. Your iterator also works in a similar fashion. That's why we picked this particular TV thing as an example here. Now, some of the rules, like if you can see, iterator can traverse even a composite object. As I said, like when you have multiple levels of object, you can use iterator, so it makes easy for you. And sometimes the memento design pattern, which we are going to talk there, memento, which actually captures the state of it, can be used in conjunction with this. And if you want to use polymorphic iterators that also rely on factory methods, they can also instantiate appropriate iterator class using this. Now coming to mediated design pattern. So what does mediated design pattern tells us this? If you want to define an object that encapsulate how a set of object interacts, that's where you go for this mediated design pattern. So mediated design pattern, it's more like, let's say when you begin a development, we have few classes and these classes want to interact with each other to produce results after you create objects and all, right? Now consider, like whenever your code becomes bigger because there are more requirements and your logic also getting complex because there are new functionality coming in, then what really happens? You will come up with more and more classes because you have to incorporate those features, and those classes again might need interaction with the existing ones as well as the new ones you built, right? Now when you want to do all that, now it becomes very much difficult when your code scales up after a certain extent, right? So that's where this mediator pattern really helps, because it more about talks about how can we encapsulate on how these objects can interact. That is what the main theme of it. And this mediator pattern is heavily used whenever you want to reduce communication complexity between multiple objects or classes. And this particular pattern provides you a class, a mediator class, which actually handle all this communication between different classes and supports, and in turn it helps you to maintain the code by doing loose coupling. Now coming to the advantages or benefits, if you want to call out, as you can see, it decouples the entire communication between classes, right? Like, it separates it out, and it decouples the number of classes. It simplifies object protocols. It centralizes this control because this guy takes care of it, and individual components become much simpler and easier to deal with because they don't need to pass messages. Earlier it is all like object object talk together. Now you're saying I'll sit between and you tell me what to do and I'll get it done, kind of. And the components don't need to contain any separate logic to deal with their intercommunication, and therefore they are more generic. So what does it mean is, earlier if you want to communicate, you will write a certain kind of logic in those particular classes so that they know how to communicate with each other. Now it is all written in the mediator itself, and since they are there, like the mediator is there, the other classes can stand aside and they can be more generic compared to earlier. And where and all it is used, your message based communication is a best example, like your chat applications, whatever Facebook chat or whatever kind of chat you're looking at, all that uses this mediator design pattern. Now, to give an example, just check about, I mean, just a brief example about a chat thing. Like for example, let's say you want to build a chat. Now two users want to interact. Now what you can do is, first you can build a message interface where you have this particular class chat room implementation, where you have this particular chat room methods, and there is another chat room class where you implement this particular interface, and after that you will just say participant class, which is an abstract class. Now then you actually use something like user1 and user2 as two classes, and the data user1 user2 as two classes. And this, when you write in main method, and this is the main method where actually you create an object to this user1 and user2 and send the appropriate message using the methods written in this chart implementation, and that's how it works here. So if you see, your user1 user2 just have information about, okay, what to send, what not to send. They are not aware of what is the actual chat room implementation is. That is taken care by different class altogether, and that's what your mediator is. The chat room implementation is your mediator being used here. Similarly, if you take other example, in Unix, you have three types of permission. If you look at, one is owner, group, others. So this others is nothing but world, everybody. If you want to implement this kind of structure also, you can implement one class for owner, another class for group, another class for others. And in order for them to communicate with each other, they can have a common class which is written, which acts like a mediator and have a communication between them. So it's like an indirect level of talking rather than indirect level of talking between objects rather than directly talking to each other. So this is another example where you see this is airplane, this is another one, this is helicopter, where all are talking to your central site, where they talk and tell you how how they are doing, or are they able to receive the signal, or or they are good to land, or they good to they are good to fly in this particular weather or not. They actually contact to a central site, right? That is, this guy is your mediator here. So rather than they talk to each other, the main principle is individually they talk to each other, just like how our objects do internally. Here we say you don't talk directly, you talk to this guy, and that guy will let you know what to do. That is how it is here. And with respect to rules of mediated design pattern, whenever you want to implement a mediated design pattern, so mediated design pattern, one thing you need to be aware is, like, you have something called, I mean, one thing to understand is when you are working on these design patterns, sometimes you mix up some of the design patterns also. Like if you look at here, we are mixing up with the chain of responsibility model where multiple objects will be waiting for your request and any one of them can serve it. And you have a command, you have a mediated design pattern, you have an observer. So all this sometimes will be mixed together. It is not like they are like independent. Sometimes you actually mix up in your project where you, in order to get more value of it, you actually mix up and deal with it. And here, if you look at mediator and observer, observer is another design pattern. We will talk about that in a while. So understand that these are actually competing patterns. When we talk about observer design pattern, you will understand about it. But just understand that these are the competing patterns, and difference between them is observer actually distributes communication between your introducer and subject, whereas in the mediator case, all the communication is taken care by a mediator class separately. And mediator, if you look at it, is similar to fake it. If you look at fake it pattern, it is similar to the fake it pattern. Now coming to memento design pattern. So memento design pattern, like the name memento, memento actually represents a state here. So memento design pattern says that So if you want to restore the state of objects to its previous state, then without violating the encapsulation, then that is the use case you can use the memento design pattern. So that's the reason it is sometimes called as token as well. Now, what is the use case if you look at is your undo or backspace. So for example, whenever you notepad, what you do, certain times you want to go its previous state. So what is undo do actually? If you have some data and what undo do, let's say you deleted it. When you do undo, what it is doing is what is your previous state without deletion, right? Like your previous state is something like this, where nothing is deleted. Your next state is where you deleted it. So when you say undo, it will just take you to the previous state, which is this. Again, when you do undo, it will just take its previous state, which is this. That means without deletion. So it captures, so how it is able to do is it captures its state. So your undo, backspace, control Z are all the examples of this memento design pattern where it preserves the object internal state so that whenever you want, you can retain it back. And what is the benefits of this approach if you really look at? It prevents your encapsulation boundaries because that's what the main principle of it is. And it simplifies the originator. That means whoever is originating it, it simplifies their architecture overall. And as we discussed, it is mainly used for this undo and redo operations in most of the software where you use it. It could be Word, it could be, your Notepad, it could be Excel. Wherever you use this undo and redo, it is nothing but a memento design pattern. And it is also used in database transactions, by the way, because database transactions also sometimes need undoing or redoing its state, right? Because there also sometimes you roll back. There also sometimes you get the database to previous state by using some log files and all. So memento can include any kind of state variables, by the way. And but if you want to implement memento, basically must have two interfaces. One is an interface to the caretaker, and that interface must not allow operations or any access to its internal state stored by memento, and it maintains the encapsulation. And other than interface, you have something called originator. This is another class where you allow originator to access any variables necessary to the originator to restore its previous state. So what does it mean is, let's look at based on an example. So if you see here, this car, if you look at, this is its original state. So you'd want to go it or previous state, it could be this. Or if it starts from this, it could be this. Or if it starts from this, its previous state could be this. If you look at here, like before car removal, this is its previous state, right? Or before wheel removal, this is its previous state. So that's what here memento. So here the part is the state of this tire being removed from this, or the state of this particular tire being removed, this is actually pertinent. And if you want to go to this state, you can come here, or you want to go to this state. This memento actually is responsible for persisting the state together so that it can get back whenever you want to go to that state. And rules like these are sometimes called as magic tokens because they preserve the state and can get you the same state whenever you want. And like I said, it can be used to maintain the state required generally for an undo operation. It is like, whenever you want to go to previous state or go back to the original previous version and all, this is the thing you can look at. And sometimes you can use with a iterator also, only when you want to go its previous state. Like when first to 10 elements you are printing using iterator, let's say you want to, instead of printing first to 10 elements, you want to go back from backside. So there also you can use the memento design pattern. Now coming to your null object design pattern. So what does this null object design pattern tells you? So null object design pattern, if you look at null object, what does it say is it is like, what do you do in order to check you in your code if it is a null value or not? Generally, you will write one if condition and you say whether the object is null, that's done, right? So here what null object design pattern says is, rather than you doing, give the responsibility of that to some other class and let that guy decide whether to give you a false value, which is nothing but, it's not exactly null, but to say that, okay, this is not what I'm intending for. And whenever it is there, an object there, you give it something else. So here the responsibility of null object, it simply says that, you just replace a null object, just replace the check of null object instance to some other object. You don't do it. That means instead of you doing, let it take care by another class. So it simply says that instead of you putting an if check value for checking this null value, let the responsibility taken care by other class. Now, how do you do it? Now, first thing, let's say take an example. Let's take an example where you have set of customers like you have set of customers and you want to, let's say you have customers like customer 1, customer 2, and customer 3, customer 4. Here, let's say in your database, these are the three guys who are authenticated and these are not there. Now, what I want to do is you can do that in different ways. What I want to do is using this null object design pattern, if I want to implement, what I will do is first I will create an abstract customer class that will have just two things. Like one is about the name of the customer, another is a nil value or a null value method I write. That's all. Now, after that, in the real customer, I'll create two classes. One is real customer, that is nothing but authenticated customer. Another is null customer, real, or I would say authenticated customer. So in authenticated customer, I will write the code for this name where it sets the name whenever that customer is authenticated. And I will set the null value to false because he is a real customer. I don't want to say it is null. Null means here understand that he is not present in our database. Now in the null customer class, what I will do is for this customer, I'll set the name and I will say that this customer is not there in our database, something like that. Now in the actual customer factory, I'll create one more class with that name and there I check if they are there in my database or not. Whenever they are there in my database, I will call this real customer class. If they are not there, I'll just call this null customer class. Here, if you observe, whenever customer is not there, I will get a message saying that the customer is not in database, but it's not coming from my customer factory class, but rather this is coming from a null class which I have written or null object that takes care of the responsibility. That's what null object design pattern is, where it simply says that rather than you put an if condition and check whether it a null value or not, let it be taken care by some other class where it does your job. That is what the entire point of this null object design pattern is. Other, if you look at multiple scenarios have been mentioned, like one is like if you see a simple screensaver where it actually puts out some kind of bars that move the screen here and there. And if let's say you want to have some special effects now in between, let's put it as a null design pattern and it automatically comes and pops you out. One example, like I said, the same example, one you abstract class you create where you have one customer who are like real customers who are not in the customers in your database, they can be here. And here whenever client calls it, so they will implement that method and here he will check whether the customer is there in their database or not. Whenever they are not there, he will just call this null object and that get takes care of saying this customer is not in my database rather than you checking whether null value x come. And whenever there is a customer available, this guy takes care of saying yes, the customer is there in my database and he is authenticated and all. So the responsibility is given to some other object rather than you doing lot of if conditions. So here if you look at the implementation of checking the null value, all that is given to somebody else rather than we take care every time. And rules, it is actually, if you look at it, is actually a singleton. So where you are actually creating a null object and then doing all the things, right? It is a singleton kind of design pattern. It involves include internally. And null object doesn't transform to become a real object at any point of time because the real object and null, if you look at, they are two different entities. This is for a positive case where we hold that the customer is there, and this is negative case where we hold that customer is not there. And if you look at, like, there are a lot of things involved, the strategy pattern and all that. Unless you understand about strategy, proxy pattern and all, this will be difficult to take it out. So what I would suggest is once I complete all this, just try to recall by looking at these PPT again, and you will get a sense of what does they mean by visitor or strategy. These are all different design patterns. So here we are talking about how you can integrate these design pattern with other things and all that stuff. Now coming to observer design pattern. So observer design pattern says that just define a one-to-one dependency so that when one object changes its state, all its dependents are notified and updated automatically. So what does it say? It says observer is more about, I would call with other name called a notifier or sometimes publisher subscriber model. So what does it mean is, like, you just have one-to-one dependency between each of them. And whenever one object, let's say they change its state, and automatically the dependents or the guys who are looking at that object, they notified and updated automatically. Okay, so that's why this is sometimes also called as dependents or publisher subscribed. Why dependents? Because the other guys who are observers are listening to a particular object to see when they should change the state. Now, what is the benefit you get? The benefit is it describes the coupling between objects and observer easily, and it provides subcode for this broadcasting. So it is nothing but if you see notification, it is a broadcasting, because here you have one object, and whenever that guy changes its state, it just notifies, and multiple guy who is listening to it, who are its dependents or observer, just change their state based on it. So if you look at, this is a pure broadcasting example. Now, how to create it? Let's say you want to create a notification mechanism. Like for example, let's say whenever a customer sends a message, like there is one object which receives the request, and whenever that guy gets the request, let's say you want to, there is this guy who gets the request from outside, and based on customer request, maybe based on customer type or something, you want to store in different database. Like one could be your S3, another could be your on-premises database, another could be your Redshift, whatever. Now, if you look at, all these guys will be listening to this particular object which gets the customer request, and whenever he notifies, these all guys will automatically update it. So these are called observers here, who look for it and automatically update their state as soon as they get the notification. That's why I said it is like a broadcasting and a publisher subscriber model, because you publish a message from here, and the subscribers, who are these, listens to your request and automatically change their state. A large model does not scale well as new graphic monitoring are required. So this is the problem. So if you look at a big design, when you actually build it, if you do not have these kind of broadcasting and all, when you have a complex system, it is very difficult to manage it well. And that is where it really shines well, where you can have this kind of, you know, not only publish and subscriber, you can say push and pull model also. Okay, where you push the message and take it from there. So here you see, this is general real-time example which you might have seen. One guy who is the auctioneer, where he just gives a bid, and that information broadcast to multiple people, and there are multiple people actually based on the broadcast message, which is the bid number or bid value they get. Based on that, all the other guys are bidding, saying, okay, I want to bid for this value, I want to bid for this, I want to bid for this, and I want, these are guys are called your observers or your dependents here, who are listening to a particular, this guy who is actually placing an auction for a particular product. So this observer, compared to all, if you look at, observer has a very decoupled interface, because it is like a notification mechanism, like I said, right? Like multiple receivers can be configured at a time, where you can say that these are all guys I want you to notify automatically, and that gets done. If you want to implement, all you need to do is just implement one or two observer classes. Like I said, one observer class, another observer class. You can implement two observer classes, and after implementing, what you can do is you can write a main method, and where you automatically, in the main method, you can just trigger a notification, and these guys who are listening will automatically update their state, which could be database or anything, based on the notification they receive from your main class. This is simple enough to implement. From your client, you just pass a notification, and these observers just update their data change, state change based on the notification you get. Now coming to state design pattern. So what does state design pattern says? State design pattern says that you change the class behavior based on its state. So we are not saying here we will update the state based on the notification. That is what the earlier design pattern is, which is this uh, observer design pattern. Here we are talking about you change the class behavior will change based on the state. So in state pattern, what really happens is we create a set of objects which represents various states. So we are creating objects to represent states. Understand that. And there will be, apart from states, there is a context object where it will change the state of this particular objects which is maintaining states based on the context. Like for example, one simple example if I want to give is, like your polymorphism is a kind of state design where when you do 1 plus 2, this guy knows that he has to add a number. Similarly, if you look in Java, whenever you give string create hello like this, how do you think it automatically knows that it has to merge these two strings saying create hello? The reason is, here it knows about the context clearly. So that's why I said state design pattern talks more about the class behavior changes based on its state. So here the state, if you look at is, here the state is two numbers. Here the state is two strings. So based on the change state, it changes its behavior. Here it understood the my state is two numbers, so I have to add it. Here it understood my state is two strings, so I have to merge it. So the behavior is changing. That's what called state design pattern is. And what is the advantage you get? Like I said, it is like a polymorphic wrapper. It's like I said, it implements the polymorphism. And whatever we discussed, this is nothing but operator overloading, which is one example of polymorphism. And this plus, sometimes you can call it as a polymorphic operator because based on the situation, it just changes its behavior. And that's what exactly state design pattern also says, where it says that you have to change the behavior based on its state. And state design pattern, if you look at what is why it is beneficial is you can using this design pattern you can keep the state specific behavior. That means your behavior changes based on the state, not based on a particular invocation, but based on the state you will change the behavior. And any state transitions you want to make explicit, this is the guide to look at. And usage, if you look at usage is something like this. You can use it when the operations have large multi-part conditional statement that depend on the state of object. Let's say you have multiple conditional statement which depends on a state, then you can use this kind of design pattern. Another use case could be when your behavior of objects depend on its state. That means, let's say the behavior is something like this. I want to call, or I want to authenticate a user only when he is, or I want to update the customer as privileged or regular only when the customer comes into so and so salaried person. So there is a state involved. There is a condition involved saying, is the salary of this person is so and so, then I want to upgrade him to this customer. So that is a state, and based on state, your behavior of where to update is changing. Let's say we have departments. A simple example: we have accounting department, we have management department, we have sales department, three departments. Now let's say these are stored in separate databases. This is one database, this is another database, and this is another database. Okay, I'm just putting it as a database picture. This is database. Now what I want to do is, in order to implement, I will create a connection interface where that will have information about opening a database. It has just an abstract method: opening database, close database, and write something to the database or update. You can say anything. Okay. Now what I want is I will create a particular, classes which actually individually update account database. For management, I will create one class which will update the management database. Sales department, I will create one day class which will update sales database. That's all. Now apart from that, what I will do is in the state databases, I will create something called a context class, which actually tells me that based on user request, which particular department I have to trigger in. That is my state. So here what happens is whenever user requests for I want to update in sales, that is means he is giving you the context. So based on that, I will invoke the respective class, which is management or accounting or sales, and I will update the database. So here the context is the input coming from the user, which tells about your department, which is account or management or sales class. Based on that, I am updating into the relevant database, which is the behavior. Now, like I said, this context class is very important because that is the guy who is actually implementing it. And your state is very abstract class because your state contains just an information about who is passing the state. That's all. But your context factory or the context class has the information about which particular state to trigger based on the state given to him. And like I said, this design pattern is basically a state specific one because your behavior or the way this particular code has to run, it completely changes based on the state given. So it is a state specific behavior machine or state specific behavior design pattern. And if you look at your vending machine, so vending machine, you will put something and get snacks. So why we are doing this is, so vending deposit state is one, vending stock state is another. So if you look at in the state design pattern, so there are two states. One is vending stock state and vending deposit state. So vending deposit state is where you are putting the money, and stock state is where you are getting whatever the stocks in it. Like there are two states here if you observe. The same vending machine can help you to serve whatever the snacks you want in this based on the money you put, which is what the vending deposit state. And the same vending state, once you put the money, can give you the whatever snacks and all here. So the same machine, it will react based on the state. One state could be you put the money and it understand, okay, this guy has put the money, what is that he want? Once he gives it, it automatically calls this guy where he delivers it. So based on the state, which is one time it is depositing money, another time it is like getting that particular snack or whatever in this vending machine. So behavior is changing based on the state which we are in. Now coming to template method design pattern. So what does template design pattern tells you about? Template design pattern, the principle is just this. So it says that you just define the skeleton of the function and defer some steps to its subclass. So what does it mean is you will just define the skeleton. It means you just define the structure of it. Don't do any coding there and let the subclass do its part. It is more about again inheritance where you're saying you just write it what you want and let the guy do it. So it is more of a technique where you're just reusing the code. That's the main benefit of it. Usage, if you look at from the usage point of view, you will use it when you want the common behavior among multiple subclasses and you want to move to a common class by avoiding the duplication. That's where it is used. Just to give an example, let's say for example, let's say there is a game and there is a chess game or soccer game or maybe cricket. Let's take this as cricket and soccer. Now, in this game interface, you will write something called a play method and you will just write the play method and you will have class separately created, one for chess, another for soccer, where you write the implementation of what and all you want it to do when there is a play triggered in chess or when there is a play triggered in soccer. That's all. Now, in the main method class, when you just call this particular play, what will happen is if you really look at like based on what my input whether I want to play cricket or soccer, it automatically triggers the play method inside. Actually, if you look at the play method here in the game interface, I have just written the skeleton of it. I haven't written the body. And this subclass who implemented or who extended this particular game actually written their own functionality, and that's what getting triggered here based on the user input. And that's what I mean by template method design pattern. Like the name here, when it says template, it simply means that you just define a template or a structure or a blueprint of the method and let the subclass decide what they want to do it. That's what it means by template method design pattern. So if you see here, like, here if you see, we have defined a template for all of these guys, where if you see for all of that, we have defined this template, which is daily routine, get up, get free, equate for work fast, go to work, return to home, relax, sleep. That is the template we have defined. And for each of them, it applies, but it applies differently. For firefighter, it might be work might be different, workhouse might be different, lumberjack, it might be different, postman, it might be different, manager, it might be different. All of them, the same operation which you have defined as a skeleton can be different, right? So this is your template method design pattern. This is your template or the structure of it. And the actual functionality where we said we will defer the implementation to its subclass is this part. So it is more like, again, when you're saying subclassing, we do the overriding part only. It is not something different altogether. And if you look at strategy is also more of template method. If you look at just that in template method, we are going little granular where you are doing the implementation and all. That's the main difference comes in. And template method obviously uses inheritance because it has to extend it to implement the functional function which is implemented function which is written as an abstraction. And strategy actually modifies the logic if you look at, whereas template modifies the logic based on that particular class invoked. And your factory method is a specialized type of template method if you really look at. Now coming to visitor design pattern. So what exactly is visitor design pattern here? So in visitor design pattern, if you look at it actually used to perform operation on a group of similar kind of objects at runtime. And it helps you to decouple the operations from an object structure. Using this particular pattern, you can easily add new behaviors to the existing class hierarchy without changing the existing code. Okay, sometimes that's the reason it is also called as behavioral pattern as well, because here you can easily add the new features without changing the original code of it. That's the best part of it. And one more thing to look at here is the primary goal of visitor pattern, if you look at, is to move the operational logic from the objects to another class. So the operational logic, whatever you want to do, you actually move to the another class rather than it takes care by itself. And whatever operation you want to perform, you actually perform based on the elements of the object structure given to you. And the whole point of visitor, why it says it, what the name visitor is, it actually lets you define a new operation without changing the classes or the classes elements on which it actually works on. And in visitor pattern, there are two main things used in visitor patterns. One is your accept method, which accept method is accepts a visitor, and that's just like a visitable class we say. And this visit method is actually called every time whenever you visit an element. It is implemented by the visitor class. And if we look at, I just want to explain this diagram. So in the visitor, if you look at, there is this taxi visitor and this cab customer company, where they are actually, I mean, the tax company, like let's say Ola or Uber, those are the company guys. And whenever you call it, so based on you get a request, this is like your visitor. He calls it, and based on that, this guy gets a request, like you want a cab, and he sends that accept visitor request. So this is your visitor request. So based on the visitor request, you get a cab, and this is your visitor here, and this is the customer who calls. Based on that, he accepts that request and sends this accept a visitor request. So the advantage with this approach, if you really look at is, the first advantage you get is you can easily add items to the system. And because here we say, when you, it is very useful when you want to add new features to it without updating the original code. And here the logic of operation changes when you want to make changes only in the visitor implementation. Like let's say you want to change this entire cab, that's where you need. Otherwise, from customer point of view, for him it is like you just call the cab and you get it. So that is the responsibility it is taken care. So these are like individually separated, this part and this part. Don't look like customer, just look them like a different classes you have altogether. One is customer class, one is cab company, another is your taxis. And it reduces the maintenance cost because the maintenance wise it is lesser, and it helps you to make the code clean and easy to read. And the type errors and all can be easily caught, and it provides high extensibility, by the way. One more example, if you want to understand more, what you can do is, generally we go to this particular thing, right? Like for getting a license of any, to get a driving license of a car or bike or van, whatever vehicle. Now, if you look at that, also can be implemented using this visitor designed pattern, where let's say you have a car, or you want to get a license for van, or you want to get a license for bike or anything. Now, let's say this has been the case. What you actually want to implement this driving license, whether you get it or not, is in this you will actually write the visit method, whatever visit implementation of this car, or whatever visit implementation of this van, whatever visit method implementation of this bike. That is what you will write it. And what you will do is there will be a vehicle interface which have just something called accept method. Like I said, this is the heart of this entire design pattern. And this accept method, apart from that, there is something called vehicle inspector who inspects your particular vehicle, whether it is a car, van, or bike. And based on that request, he will say accept, right? And that vehicle inspector will have this method, abstract method for car, van, and bike, which is this visit method, which is what implemented in each of these subclasses. And vehicle inspection, which is this particular vehicle inspection, is another class where actually based on which vehicle you want, he will look at it, and based on certain criteria he will say, okay, I'm accepting your request. And he will visit whatever, based on your request he will visit, whether it is a car or vehicle, and based on that he will accept and serve your request. That is another example you can look at for these kind of design pattern use cases. This is also a composite design pattern, just like how you have the iterator and uh, you know interpreter design patterns. And iterator can also traverse a composite design pattern, just like how we have here. And Vista, if you look at it, it's more like a command pattern, right? Like, because you have a separate, you know, you have a separate accept and you have a separate visit. So there is an accept request which acts like a command here. Now, that is all about our core Java design pattern. Now, if you look at the J2EE, that means enterprise design pattern. So J2EE is basically for this design patterns are basically for these help actually to build for the development of enterprise web based applications. If you want to build it, so these are the design patterns to look at. And in this, there are mainly three types of design pattern comes. These are those three, which are presentation layer design pattern, business layer design pattern, and integration layer design pattern. In presentation layer design pattern, you have something called intercepting filter pattern and friend controller pattern, view helper, and composite view. Whereas in the business layer pattern, you have business delegate, service locator, facade, and transfer object pattern. In the integration layer design pattern, you have something called data access and web service broker pattern. So yeah, that's all we have. So to summarize, overall, if you look at, so what we have learned here. So overall, what is the purpose of the entire design pattern? We understood about a lot of design patterns. I think we understood close to, if I count correctly, close to 20 design pattern, if we count all of them. So, but overall, what is the essence of it? So if you look at the overall gist of is, we are not saying that you have to use everything. That is first thing you have to understand. What we are trying to say is these design patterns are not something like a programming language driven or programming language enforced. These are the design patterns where people like you have actually encountered problems in their projects and they come up with certain solutions or approaches, I would say, where they tell you that if you follow this approach, you might be able to build these things like this and use cases which they have encountered. Like we are talking about publisher subscriber model, or we are talking about object state persistence, or we are talking about behavioral change based on the object state. All these are different kind of projects which people have worked and come up with different design patterns so that they can help in your project. So what I'm saying is, like, before you work on any project, look at the problem clearly. Like, what kind of problem it is? Is it like a problem where you want to do something like a publisher subscriber model where you want to send notification to multiple people? Then you might need to look at one of the design pattern we have called observer design pattern, where it observes and based on that the other classes just update its stage based on the change in one particular object. That is your object observer pattern, isn't it? Now, similar to that, let's say you want to change the behavior of your object based on the state change, which is what we have discussed about state design pattern. So that is another thing to look at when you have similar problems. So more than that, it is not like every project is in need of it. You have to understand your problem of that particular whatever project you're working. You have to understand your problem carefully and see which of these design pattern helps. And sometimes you might use one or two design patterns or two or three. It all depends. But always see which problem actually fits for use case, which use case, given that this many design patterns are there. So as these are mostly experienced by multiple people and they are like as a convention across the industry people follows, it is good to use these design patterns so you can develop your projects in a better way, rather than reinventing the wheel. When I say reinventing the wheel, rather than you come up with a new solution, look at whether any of these solutions possible for your project use cases. If not, then it definitely gives you an opportunity to come up with a new design pattern. So that's all I want to summarize. Key takeaways: look at what kind of problem you're dealing with, understand it carefully, see which of the design patterns existing fits for that, and one of them fits it, apply it, and see how it works well. And as people have done it earlier and they have seen success with using this design pattern, definitely you will also see good results. And it's not necessary that only one design pattern is useful. Sometimes you might end up using multiple design patterns also. So today we will look at one of the design pattern and we will implement a use case, a day-to-day VC kind of use case using one of the design pattern called factory design pattern. So this factory design pattern or factory method pattern, so what actually it means is you have a set of factory of classes for different use cases kind of, and based on which particular choice you opt, we will give that a particular class will be given to you or particular option will be given to you automatically. So let's put it like a real world use case. If you look at Netflix, you might have heard about Netflix. I mean, everybody knows about Netflix. If you want to get a Netflix subscription, there are three basic plans. If you observe, one is basic, standard, premium. Each has a different rate. Now, you can implement the same scenario using factory design pattern where you can have one class for basic, another class for standard, another class for premium, and based on the user choice you can have the respective class coming in. This exactly fits for our factory design pattern use case. So we will use the same use case and work on it. So let me start my Eclipse IDE. So let me start it. Okay, so let me close all this. So this is my test project. This I have a source, and in that I have a demo package. And in the demo package, like we are doing programs till now, I'm going to create a program. The first program I'm going to create is, this is a Netflix use case I'm implementing using this factory design pattern. So first of all, I need to have a set of classes which actually help me to give the relevant option for the user based on the choice he makes. So let me create uh, a Netflix plan abstract class. Netflix plan. This is an abstract class I'm going to create, and this one is basically an abstract class. And what these will have, this one will have information about the price, and there is another method called abstract int get price, and there is another thing called get final amount int months. This is a concrete method here, return price into months. So that means based on the choice he makes, we will calculate the final amount. He will give how many months you want to subscribe this basic, standard or premium plan, whichever the choice he has, and based on that how many months you want to subscribe, we will calculate it and print it. This price will be coming based on the plans. So now what we need to do is we need to implement those plans. So let's start with the first plan, the basic one. The basic one, how it looks like. So the basic plan looks like something like this. Let me create a class here. This is a basic plan. This is a basic Netflix plan. It has to extend the actual Netflix plan we have, this one. Now we have to implement the unimplemented methods because that is an abstract class. So here we are going to say, if somebody calls this the basic plan, I want to make it public so that everybody can use it. The basic plan, if you look at net, I have picked this from internet. Like if you want to see, you can go to Netflix and check that. I just picked from there. Netflix, if you type it and look at it, and if you want to subscribe, you will see plans when you register. So if you come here and sign in, they'll ask you certain details. After you signed in, they will ask you for the plan. I picked out the same cost and everything from there. Let's see if I can directly show you the Netflix plan, subscription plans. So you see, choose your plan. So next. So these are the ones, basic, standard, premium. So what is the basic price? $499, $649, $799. I picked the same thing from there. So here, what is the basic price? $499, right? So I'm putting it here as price equal to $499 monthly. These are all monthly plans. If you observe, these are all what they have given as a monthly plan, monthly price, $499. I'm not taking mobile into consideration, and return price. This is one thing. This is done. Now we have the basic plan ready. Now similarly, I want to create another plan called standard. Standard. Now this standard plan, again, it is going to extend the Netflix plan. So since it extends, it has to implement the unimplemented methods, and unimplemented methods is the price. And what is the price of the standard plan? $649. So price is $649. So you might be wondering from where he is setting the price, isn't it? So price, if you see, it is coming from Netflix plan. This is a protected variable. That means all its inherited one. These are all inherited one. They are actually using the same price. Just that for each class, the price is value is different. But this price is whatever price I'm using in standard, this one in basic, these are all coming from here. Okay, so return price. So standard is also done. Now, so factory method is nothing but you have a factory. You have a bunch of different classes for different purposes, and based on the user choice you will give something. That's what actually the overall thing is. Now basic is done, standard is done. Now let's implement premium. Premium is also going to extend the Netflix plan. So implement the unimplemented methods, since we are, that is an abstract one. Again here the price is, what is the price for premium? The price for premium is $7.99. So we are putting $7.99. Then we are saying return price. Just make this public so that there is no problem, because we are going to call from main and we don't want any disturbances, so we are just making public. By default, if you don't make public, it will be considered as a default method. So now that we have a factory of subscription plans, one for basic, another for standard, another for premium. Now when user chooses, we have to automatically give that particular class to him, basic or standard, based on the user choice. That is what the overall purpose is. Now for this, we need a controller method or a factory method, or sorry, a factory class. So why it is started doing it? A factory method we need. So for the factory method, what we will do is we'll create one more class. It's like a controller. It acts like a controller here. And the method, the class name is something like this: Netflix plan factory. Netflix, okay, why? Okay, Netflix plan factory. So this is the one. This is acts like a controller. In this Netflix plan factory, we'll say public Netflix plan. We have get plan string plan. Okay, and what is this get plan? Add return statement, you can add it. And here this get plan is what we are going to call in the main method. First one, if plan itself is null, I mean if there is no plan given, then we will happily return the null value. But if there is a plan set, let's say if the plan is equal to, the plan is equals, we need ignore case. The plan name is basic. The plan name is basic. What you want to do, you want to return the basic class instance. That means you want to return this if the plan name is basic. Similarly, the other things we'll do here. If the plan name is standard, then we are going to return the standard object, this one. So we made it equals ignore case, so that even if user enters lowercase or uppercase, it is easy for us to compare. There will not be any problem. Otherwise we have to restrict user saying only enter uppercase, not lowercase and all. Again, we have one more plan, right? And that case name is premium. And if A enter, we will return the new premium object. So that's it. So now we are ready. That means we have a controller or a factory class which actually gives you the respective subscription plan to the user based on whatever it is defined. Okay, now what we do is, now we will write our main method which actually makes use of all this stuff. Now let's start our main method. Okay, let's put a name like factory pattern program. this is our main thing. So we have to write the public static void main string args, and here we are going to use scanner because you have to take the input from user. So for input I'm using scanner and just setting on system.in, so that whenever system.in stands for your refers to your keyboard, so that whenever user enters something on the keyboard, it automatically gets from there. So since I put system.scanner, this is a package, I need to import that. So I have imported scanner. Now this is like declaring the setting the input stream. So the input stream is set. Now we are going to have one Netflix plan factory, which is our controller, and we say plan factory equal to new Netflix plan factory. So this is the, we have that now. Now we'll ask user system.out.println enter your plan, enter your subscription plan, maybe that is the right term. Now he will enter the subscription plan, we need to read it. So we are saying user choice equal to se.next. Now we pick the user choice. Now after picking user choice, again you have to ask how many months you want it. The subscription you picked it, that's well and good, but for how many months? Enter how many months, enter for how many months you want to subscribe the plan for. That's what we are asking. And here he is going to say, he will give you a number, which is what we read as integer. Now we know what is the plan he subscribed. Now what we will do is Netflix plan equal to plan factory dot get plan of user choice. Okay, so now you have set the plan. So this get plan net plan factory, if you look at, this is your factory, you are calling this one. So you are calling this get plan, and your whatever user choice is, you are calling this. So now what happens is, in this program you have set it saying user choice is so and so plan, either standard, premium, basic, whatever, and this is called this method. When this method is called, it already knows what user set, whether it's a basic, standard, premium. So based on the user choice, this guy, the plan variable, already gets the relative class instance like standard, premium, Netflix factory, because if you see in the code, we are returning that. Now here what we are going to write is, here we are going to actually ask the user, actually give the user based on what he entered, we are going to give him the details saying, okay, you opted for this plan, so your monthly bill amount for the plan is, we are going to say for your monthly bill plan amount, the amount you're going to have is plan.getPrice. This method, if you remember, we have defined in everything. This one, it calls this, it will return what is the basic plan set. You see here, this is the one. Okay, now that's what we are using there. And here one more thing we have to give is overall bill amount, because we gave monthly how much it's going to cost for him, and at the same time we have to give the overall bill amount, because he opted how many months, like if it is monthly 599 and he opted for 5 months, you have to multiply 5 into 599. That's what you are giving here. Overall bill amount for the plan is, and we are saying here plan dot get final amount, and what is your n is nothing but months. That's what you are going to pass. Now let's see that in action. Now let's put creating factory controller. I'll call this as a factory controller for Netflix. And here I would say taking users subscription choice, and here I will ask taking number of months user want to subscribe the plan for, and this one is like setting the plan. So here is where we are setting the plan user has chosen. And after setting it, now here is where printing the monthly price and overall bill amount details. Okay, now run this guy. Now I ran it. It is asking what is your subscription. I said basic. Now he's asking how many months you want to subscribe. I said 5 months. Okay. Exception in thread cannot invoke demo.netflix plan.get price because plan is null. Okay. Why plan is null? Basic, right? Okay. The problem is I have given a wrong name. So that is not matching any of that. So that's why, since it is not matching, it is returning null. That's the problem. Okay, you have to give the right one. Now let's run again. Basic. And how many months? 5 months. So you see, now what happened? So you gave basic, so which is what read here, user choice. Then you gave the number of months you want to choose this plan, which is what 5 comes here. Then when you said plan factory.get plan of user choice, it has set the plan. You have given basic, so it matched this and it returned you this basic method instance. That means you have this as accessed here. That means this plan is assigned as basic object. That plan variable is assigned as basic object. Now when you say plan.get price, what you will get is you will get this, which is 499. That's what it is showing up. Now again, you did one more thing. You said plan.get final amount. Get final amount is not part of this method, but it is part of the Netflix plan amount. In Netflix plan amount, get final amount is there. So when you call this, since it is an abstract class inherited by basic, as you know, for inheritance, whenever you inherit certain method, it is not only just the variable, the methods also will be available to you. So this method is also, you can consider like available here. So you can use the same method here, or whatever it is Netflix in the super class, you can use it here. So you are using it and calculating the total amount, which is nothing but price into months. Okay, similarly, let's try for, you know, standard, and let's say it is for 3 months. So standard, it says the amount is 649. See, this is the amount 649, and it multiplied 3 into 649. Similarly, let's try for premium. So for premium, here also you will get null. I gave two i's here, so you will get the error. Premium, I said 5 months, so it got the answer. Premium is this one, 799, and it has calculated the final amount from this. So you are getting the answer as 3995. So this is how you can implement the factory design pattern, where you have a bunch of classes with a particular responsibility, and based on the user choice, you can give that respective. The name why the factory pattern is because you have a factory of classes having one specific job for each of them, and based on the user choice, you can do that. And how it knows based on the user choice how to pass it to the respective method is what this controller class does. The controller class job is to send you the required class object based on the user choice. That's what happening here. If at all it is not matching to anything, we have set plan equal to null, because when you set the user choice and when you say get plan of user choice, when you set, let's say user choice is not standard, not basic, not premium, it will come here and it will check. If it is not matching, it will return a null value. Okay, so instead of null value, you can also put a message or exit by doing a system.out.println and saying, okay, the plan is not matching to basic or standard or premium. Ideally, you have to give these three. Since it is not matching, I'm terminating like that also you can do, because we allow only standard or premium or basic. So you can even give that. That is also possible. Okay, that's all I have. I hope this helps on how to do different kinds of use cases and factory design pattern. So not only this, you can design a factory design pattern for other use cases as well. Like for example, assume like a use case like where you have you know something like a mobile phone. If you see a mobile phone, you have different recharge options when you look at postpaid or prepaid. In postpaid also, maybe 200 plan, 500 plan, 800 plan. So you get different data pack, you get different kind of talk time free and all that, right? You can implement the same using factory design pattern. You can write one for each plan. You can write one classes which are nothing but the classes which actually does one specific job. And finally you have one factory controller based on the user opted mobile plan. You can give him that. So anywhere when you have bunch of things to taken care, and there should be some guy who is controlling it, which one to give it to you, this one works very well. I hope this helps. Try for other scenarios also. Thank you. So we are going to learn about how to implement some of the design patterns in Java today. So first of all, we are going to learn about one of the behavioral design pattern. So let me close this guy again. So one of the design pattern we are going to learn, like as we know, like we have three high level design patterns available. One is the structural design pattern, creational design pattern, and behavioral design pattern. We are going to learn about behavioral design pattern today. In behavioral design pattern, we are going to implement a use case using one of the behavioral design pattern, because in behavioral you have different types of design patterns. Again, in that we are going to learn about one of the behavioral design pattern called chain of responsibility model. So in chain of responsibility model, the idea here is, you know, I mean, whenever you have a use case where you need to flow the responsibility from one particular class to another, you can go for chain of responsibility model. And it is very useful in certain use cases, like for example, if you take a use case of a bank approval, which is what we are going to see as a demo, where in bank generally what happens is you have an approval based on the money you are asking for a loan. Let's say you are asking for a loan amount 10 lakh something, your assistant manager might be sufficient enough to approve it. Or let's say your loan amount is 50 lakhs or 1 crore, maybe you need approval from the bank manager. If it goes beyond, maybe RTGS manager. So the approval chain goes from one person to another based on the amount you do. So we have some hypothetical use case where we will put some amounts, and based on the amount, automatically the responsibility chain moves from one particular class to another based on that. So that's the whole idea of using the chain of responsibility model. And today we are going to implement this the behavioral design pattern, which is this chain of responsibility model for a loan approval process. So how to do that is what we are going to discuss. So I already have this project created test. Inside I have this package called demo for all demo programs. Here I'm going to create a class first called approver. So this approver class is what I'm going to write. This is an abstract class basically. So this is my approver class. Is public abstract class, like I said, abstract class. And in this you have an approver variable which is of type approver variable successor, which is of type approver itself. And you have one more method called pass to successor. So this is the method actually based on the amount will help you to pass. And this guy, what it does is he help you to set the successor for us. Now we have another function here, which is an abstract function, which will process the request like this. This is an abstract class where we have defined an approver abstract class. In that we have a successor variable which is of the same class type, and this variable is what actually we get from the user to say, okay, pass this guy as successor if at all amount is above something like that. That's what we are going to do, and this function help us to do that setting where if at all amount reaches to certain value, this guy will be taken care. And process request is where you actually process the loan request, and since this is a loan class type, you're supposed to create a separate loan class. So let's do that. Let's create a loan.java file. And what is this loan.java file contains? This loan.java file actually will have the 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 actual information about what actually loan should contain. So I'm taking a very very few variables here. So one basic, if you look at a loan, basically you need a customer name, you need a loan ID, and you need a loan amount. Basic thing. There could be a lot of things, documents and all, so we are not worrying about it. We're just taking a simple use case. Based on this, whatever I have shown here, you can extend it further. Now here we have a public loan constructor where that guy will take ID, he will take amount, he will take name, and here we are going to write this dot loan ID equal to whatever the ID user passed, this dot loan amount equal to the amount user passed, this dot customer name equal to name user passed. Now once this is done, we'll have some few more methods where whenever user asks for loan ID, we should be able to give them easily. So for that, we'll say return this dot loan ID. It just returns the loan ID of that particular instance. Okay, what does it say? Public string get loan ID. Set string cannot be resolved to a type ID. Okay, there is 2t here. Okay, similarly, then we have one more public method where if somebody asks about the loan amount that particular user have taken, it will give us that information. So we'll say return this dot loan amount. Similarly, if somebody other asks this customer's name, you can say get customer name and return the customer name. So this is what the loan is. So the loan class contains simple information like the loan ID. Every loan will have an ID inside banks, the customer name who took the loan, and what is the loan amount he is asking for. And here is the constructor where while he is creating object, he will pass this information and these will set. And whenever somebody asks for this loan ID, we will return the loan ID. Whenever somebody asks the customer's loan amount, we will return that. Whenever somebody asks about the customer name, we will return using this method. So this loan part is done and approver is also ready. Now we need to actually write the implementation, like the approval chain kind of stuff. Now let's start with the assistant manager guy. So let's create assistant bank manager. So we are going to have three classes, three approvers, I would say, three types of approvers, and each one will extend your approver class. Okay, and when we extend it, obviously you have to implement all the unimplemented methods. So here is in the process request, here is where we are going to write code saying if this guy, this assistant bank manager, if he gets a loan amount request for, let's say, amount less than 10 lakhs, 1, 2, 3, 4, 5, 10 lakhs, then he can approve it. System.out.println, and here I am putting this dot get class. This is to get the class name who approved it. Here in this case it will say assistant bank manager, and this is to get the method name which approved it. Here in this case it will be the process request, and after this say approved loan request ID. We are mentioning the loan ID. So how to get the loan ID? Get loan ID is the function we have written just now. For which customer? For customer, what is the customer name? How to get the customer name? We have a method called loan.getCustomer name. Those are the methods. Now this is when loan amount is less than 10 lakhs. What if it is more than that? He is not the right way to do that approval. So if it is less than that, then what we will do is, so this else, it is like when the successor is there, when the successor is not set, what he will do is he will set the successor as successor dot process request of loan. So that means ideally it will check two conditions. Where the loan amount is less than 10 lakh, he can approve. Otherwise he can't do anything. Otherwise there could be other use case where the successor itself will be not equal to null. That means successor not equal to none means when it comes to this class, so if at all he cannot process it, is what this function with this particular block means is, if at all he is not able to process when it comes here, the successor will be set to this guy itself. So it is indirectly saying if he is not able to approve, pass this to another guy. So successor dot process request and all. Okay, we will see it, like I'll show you how the flow works. Now coming to, we have to create another approver, which is bank manager. Bank manager. So here the bank manager, we need to extend this guy also should extend the approver. Extends approver. Now he extends approver, then we have to implement the unimplemented methods. So we are implementing here. Again the same code, exact same code we are going to write. So we are saying if loan dot get loan amount, he has rights to approve loan up to 30 lakhs. 30, 1, 2, 3, 4, 5. So it could be even more than that. Just think like this is a general use case and you can just changing the numbers based on whatever the loan amount you want to get it approved. This dot get class just to get this class name, which is bank manager, and this dot get class dot get simple name. This is to get the method name. So it is just to know that from which class this particular message has come. Approved loan request ID plus loan dot which ID, get loan ID, and for which customer, for customer, and what is the customer name? We have already written the method, so that is it. Now what if he is not able to approve? Then your successor, we are going to see where we are going to set the successor in the main method that we haven't written yet. There we will actually have this successor information. So here I'm just processing it to another guy. That's it. Now this is also done. Now the loan can go even higher. I mean, there could be another guy. Like what if the loan amount is above 30 lakhs? So let's do that use case also. This guy is RTGS manager. It's like real-time grossing. Some expansion is there on the banking sector. This is generally, RTGS is generally the bank where they actually give you home loans and all. So here also this guy extends approver. Now when he extends approver, you say add unimplemented methods. Here we are saying if loan dot get loan amount, he has, assume he has rights to approve up to 50 lakhs. 1, 2, 3, 4, 5. You can say, don't he give 1 crore loan and all? It is possible. Just think this is a use case we are developing. So if at all you want to change the numbers, you can change it for sure. But I'm just putting a hypothetical numbers like 30 lakhs, 20 lakhs. So it is easy for us to play with it and understand how this works. This dot get class, get simple name. So then we have approved loan request ID, and you have plus loan dot get loan ID for which customer? For customer, and what is the customer name? Loan dot get customer name. So now this is the one. Now what if it is not the case? Then he will set the successor to next level. You can have as many approvers as possible. Here we have put only 3 approvers. Now here we are going to write successor dot process request. No, so this is also done. Now we all have 3 approvers. Assistant bank manager, he will approve for up to 10 lakhs. Bank manager, he will approve to 30 lakhs. RTGS manager, he will approve to 50 lakhs. And we have this loan where actually user will set this loan information, like what is his ID, what is his customer name, what is his loan amount and all. And these are the guys who are different types of approvers based on the amount you pass. And this is main approver class where actually this is the main approver class, which is an abstract one where actually you have the code for what and all attributes the approver will contain, like the successor method as well as the process request method. Now we will write the actual code. Loan approver demo. Now here, this first one, our public static void main, now in this we are declaring variables. First of all, first one, approver. What is the different types of approvers? Assistant manager, manager, RTGS manager. These are our different levels of approvers, and you need this variable also. So these are the variables. Now you need to create the required class objects. Now here we're going to say assistant manager equal to new assistant bank manager class. Similarly, to say mgr equal to bank manager class. Similarly, what does it say? Bank manager, create method bank manager. Why? Oh, I have put new, I missed new here. Okay, so it also creates a class. Then you have RTGS manager equal to new RTGS manager. So we created the respective instances. Now you have to set the successor. So setting the successor. So this, if you remember, we are checking if successor not equal to null in each approver classes, right? Bank manager, assistant bank manager, RTGS. That successor is what is set here. Setting the successor at each level. So we are saying, if at all, we are saying the setting the successor. So assistant manager, next guy who can approve the loan beyond the limit of what assistant manager can do. If you remember, beyond the limit of what assistant manager is, the limit of assistant manager is only up to 10 lakhs. The next level after him is bank manager. For assistant manager, the next level of approval chain or the next successor is bank manager. For manager, it is RTGS manager, another manager kind of. Now we have set the successors. Now we are saying demonstrating the loan approval process. Now let's see how that works. Now here you're going to say first guy, let's say first guy who is taking a loan and his loan ID is 2021. These are some abstract numbers I have made, 1, 2, 3, 4. And he took an amount for, let's say, something like 30 lakhs. Let's say it is for 50 lakhs. Let's put 50 lakhs, 1, 2, 3, 4, 5. And the name is Harish. Now we will say, okay, this is the loan amount he took, and we are passing that to our assistant manager, saying please process the request of this guy. Now let's run this. We'll go step by step. I'm running it. If I run it, so what did happen? So there is no guy who can do beyond 50 lakhs because our limits for RTGS itself is 50 lakhs, right? Because it should be lesser than that, because let's say our bank is very poor, it can't give more than 50 lakhs. That's why 50 lakhs is the limit. And when you are asking for a loan approval for 50 lakhs, he can't do that. So let's just for fun, let's reduce to 40 lakhs. Now see that. Now see. So what happened? So you actually pass the request to assistant manager. You never pass to RTGS manager if you observe. So when you call this assistant manager dot process request, he will come here, he will check is that amount 40 lakhs less than it? No, it is not. So what will happen? He will pass to its successor. Who is the successor? Who is the successor of our assistant manager? It is manager we have set here. So it will pass to the manager. It will come here and it will check is the loan amount less than 30 lakhs? No, that is also not there. So now he will pass to his next successor. Who is the next successor of bank manager? RTGS manager. Now the flow will go to there. Now it will check is the loan amount which is 40 lakhs less than it? Yes. That's where it says RTGS manager approved loan for request ID, and it prints this information. So RTGS bank manager means this is the class name. How it is coming? Because of this dot class name got get simple name. It is printing this class name, and it says that RTGS manager approved loan request ID this for customer. So this is called chain responsibility model, because based on the loan amount, if you see, it automatically passed the approval because you started from assistant manager, but it automatically passed to bank manager, then it automatically passed to RTGS manager. This is called chain of responsibility model, where it passes the responsibility from one guy to another. Now like this, let's create one more. Okay. So we are not creating multiple. If you observe, we just created instances, and after that we are just passing request to one guy. And generally how it works, like when based on the low amount, it automatically sends to another approval level and all. That is also happening here. That is the exact thing happening here. So let's say this is another loan ID and the amount is 20 lakhs, for example. And the guy name is, let's say, Krishna. He is asking for 20 lakhs. Again, we are calling assistant manager dot process request. Now when you do it, there are two statements. First one, we know RTGS manager. Now in this case, you pass the loan request to assistant manager. Now what will happen? This assistant manager, it will go the request. You are asking 20 lakhs. Can he do 20 lakhs? He can't. Now what he will do? He will say, is my successor set? We already set in the main method. We already have set the successor here, if you observe. Who is the successor for assistant bank manager? It is manager. So he will send that loan request to that manager. So bank manager it will send. Now he will see, is 20 lakhs can I process? Yes. That's where it says bank manager class, because we are printing this dot get class dot simple name. That is what prints this. Now bank manager approved your loan request for this customer because it is 20 lakhs. He has the right? So you see automatically the chain is flowing from one class to another. We are not doing anything. Now why should we leave the assistant manager? Like poor fellow, he is not approving anything. Everybody is coming beyond this, right? So let's create one more scenario where he can approve it. We let him also do some work. Okay, I'll put something like Hitesh. Now Hitesh is asking for 10 lakh loan. Now again we are saying assistant manager dot process request. So first it will go to assistant bank manager, and let's see whether he will do something here or not. So now when you called it, now you see he is able to approve the loan, because the amount is 5 lakhs and assistant manager has right to process up to 10 lakhs. So he said, yeah, I can approve it because I have this limit. And he said, I approved assistant bank manager class, saying I approved the loan request ID for this customer Hitesh. That's it. Okay, so you can see the flow is automatically passing from one guy to another. And one more thing to keep here is I'm starting from assistant manager always. So it all depends on from where you start, because when you ask for loan, there is some set of cycle. It will fall from one person to another, right? So if at all based on your loan amount, you can directly call here. That is also possible. But here, if you see, you can clearly observe the flow automatically goes from person to person. Now here, one edge case is beyond 50 lakhs. We didn't put any class, right? Beyond 50 class, we didn't put any approver. So if you give beyond 50 lakhs, it will just keep quiet, because beyond 50 lakhs nobody is there who can approve the loan. So that's what the scenario we already have seen. So if you see here, let me put one more use case where it is beyond 50 lakhs. We have approvers, our bank is very poor that we can approve only up to let's put this as 60, only up to 50 lakhs. And if you put Rakesh, now if you run this, the last, it will not do anything up to this only. This one never works, because you don't have anybody who can approve beyond that. Either you have to give an extra right to say, either you change it saying to something like 70 lakhs, let's say, let him give a high responsibility. Now run this. Now the fourth one also he can approve, because his loan request is 60 lakhs, which he only can do. The request for 60 lakhs will go first to assistant manager. Assistant manager says 10 lakh I cannot approve. So he passes through his successor. Who is the successor for assistant manager? We already have set here. Successor of assistant manager is manager. So he passes to manager. Manager checks the amount and the loan amount is 30 lakhs. He says I also cannot do anything. He will pass to his successor. Who is his successor for manager? It is RTGS manager. He will pass to RTGS manager and he check whether I can process 60 lakhs loan, and yes, he can process. That's where he says, yeah, I can take care of this request also. So that is how flow goes from one person to another here. Similarly, one more thing to note here is, you should not be like, let me show you one more edge case here. Okay, edge case is something like this. Something like this, where let's say you are given a very less amount, 5 lakhs, and instead of calling assistant manager to process your request, you directly called RTGS manager. It's not required because this guy itself can process the loan. But what is the amount you have given? It is 5 lakhs. 5 lakhs? Yeah, 5 lakhs. This guy name is maybe Aminesh, and the loan ID is something like 789. Now run it. Now what happened here? How many requests you see? 1, 2, 3, 4, 5. Okay. Now Aminish loan request is also processed by the RTGS manager, if you observe, because this guy has responsibility to authorize any loan less than 70 lakhs. Okay. Actually, if you see, we don't need up to RTGS manager. Even if you give here assistant manager or manager, that itself is enough. So let me put it like RTGS manager, when it goes anything less than 70 lakhs, he can approve. But instead of this one, you pass to any guy here, all those guys can approve. Even if you pass to manager, he can also approve, because the amount is lesser than that. Manager dot pass. Oh, I'm doing this. I should not be doing this. Manager dot process request. Now say this time your bank manager will approve the loan, because he also have a limit that he can process 30 lakhs. What you're asking is just 5 lakhs. Okay. Similarly, like if I put something like assistant manager dot process request, this guy can do it because he has a rights to approve up to 10 lakhs. So he can also do it. Okay. So the overall flow you need to understand is, you can directly pass a small amount to a bigger guy also, but the recommendation is always start with a smaller guy, so that based on the amount it will automatically pass the flow to higher people. Like let's say if he is the head, you can simply say anything greater than some amount he can process. Something like that you can write here. And here the beauty of this design pattern is, you can have this loan approval process. Generally how the cycle works, first actually there is a representative comes to your house, he will check whether all the documents are correct and all, and he will authorize. Even you can have that representative as one class here saying bank executive approval. You can have one bank executive.java class. In that you can say that verification as one of the approval process. But here we are talking about the bank loan amount. That bank loan amount he will not approve. He will first go to his assistant bank manager, check the documents if it is correct, all that he will authorize. And if at all loan amount is lesser, the assistant manager itself will take care. Otherwise he will go to bank manager. All that will flow. So here we are talking about the bank loan amount. That's why we are considering it. If it is not the bank loan amount, let's say if it is related to approval process in terms of verifying your documents are valid or not. So then there is other thing. He will go to bank executive will verify it. Once bank executive will verify it, there is another approval goes where they check with the builder, is that correct? That also you can build it. Here the scenario is completely based on the loan amount. That's why we have put the assistant manager, bank manager, RTGS. Even there could be other levels also which we might not sure. Some of them I have picked is from the Bank Bazaar or these websites where they provide loans to different things. But you have a better idea of how the loan approval process works. You can even make it more better. That is one thing. But not only on the loan amount, what I was trying to convey is you can have different approval process. Like for example, you can even create a chain of responsibility model, which is one of the famous behavioral design pattern, to implement a scenario where, let's say, you want to join in a school, how the approval goes. Like first you go to your administration, that administration will see whether this guy is ready to, they will conduct a screening test, and if that guy is passed that screening test, that is like first approval saying yeah he is good. Then it will go to the vice principal, or then after vice principal, principal, the flow goes like that. And sometimes if it is a management seat, it go up to board also, the board of members. So it is all like that. So anywhere where you want this approval to flow from one chain, one level to another, you can use this model. Okay, that's all. I hope this helps. Thank you. So we'll start working on one more design pattern today in Java, which is called state design pattern. So state design pattern basically means, like, based on the state, the behavior of the method will be changing, or the behavior of the system will be changing based on the state. That's what called state design pattern. And we will implement one of the real world scenario. Like we'll take some of the things as hypothetical. Like we actually, what we do is, let's consider there are multiple databases like S3, MongoDB, and RDS. Now based on the state, automatically you should be able to connect to any of the database. That's what the overall purpose is. We'll not be directly connecting, but we'll be just showing hypothetically how that happens so that you can extend the code later. So let's start our Eclipse IDE. So we have a test project. Inside that I already have source folder. In that we have this demo, and demo is where we are creating all the programs, and this demo is a package. So here also we will create a class to implement the state design pattern. And so here first of all we implement logics for first we write a database connection, and that database connection will have something like this, the database connection class. So this is, you can call it like, so database connection. So this is our class. In this class what you have, so what you are going to have is, this is basically an interface. So in this interface you're going to have two methods, public void connect. You can have even more, I'm just considering only two, and close. These two are the ones you're going to take it into consideration. Now what we are going to do is, apart from this, we are going to define new databases, like starting with, let's start with maybe S3. So we'll say S3 is one of our class, where this guy will implement the database connection, implements database connection. So this class is, this interface he will implement. So since he implemented, we have to implement all the unimplemented methods. So here we are going to write that system.out.println connecting to S3 store. Similarly, When you close, it is like closing the database connection. You can say system.out.println, closing the S3 store connection. There could be even more for S3 like authenticating and all. You can even add that, but understand, understand that when you have a database connection which has these which is like an interface that has this connected close methods, which is separate for each of the classes. Like that, you will be implementing how to do the connection and close. Now let's create, like we talked about MongoDB also, right? Let's create another guy like MongoDB. So MongoDB. Now here also we'll implement the interface database connection. So as we say database connection interface, you need to implement the methods in it. And here we say connecting to MongoDB database. System.out.println, closing the MongoDB connection. Okay, now similarly we spoke about one more. Let's say maybe DynamoDB. DynamoDB. Now here this guy also will implement database connection. Now since we need interface, it is implementing. Now he will write the code for it. System.out.println will say connecting to DynamoDB store. Then it will say system.out.println, closing the DynamoDB connection. Now we have different classes which has the respective implementation of how to connect, how to get the connection out and all. Now we have to write another class called controller, which is what actually help us to do all the scenarios. Like we said, state design pattern. That means it will set the state, and based on that your system behavior will change, right? This guy is the one who does the job. It's a controller. In the controller, what we do is we have public static MongoDB mgdb. Similarly, we have public static s3. We have s3. Similarly, we have public static DynamoDB. Have DynamoDB. Now we have one variable here which is called database connection class type, which has this one as this connection variable is of type the database connection. Now what we do is there is this controller constructor where we create different instances for each of them like this, and for S3 also new S3, and for DynamoDB new DynamoDB. Now the constructor is created. Now here we'll say public void set MongoDB connection. Here we'll say connection to mgdb. So here if you observe, you are setting the state. You're saying when you say set MongoDB, your connection will be set to this. Similarly, if you say set S3 connection, the connection will be set to S3. Similarly, if you say set the connection to DynamoDB, it will be set to DynamoDB. So this connection is set up. Now you will have a separate connect and methods, close methods, which actually does the connection part for you. And there is this close method where it will implement the close for you. Okay, so this controller is set. Now this controller we are going to use in our main program. So now let's write our main program. So let's name the main program as something like state program demo. Now here we have public static void main. And here this guy will have one more variable, which is controller. That's a variable he is going to use. And this is going to create controller instance. It says there is a problem. What is the problem? Cannot make a static interface. Okay. I think this is the wrong place. Let's do that in constructor. Now there is this constructor where when the connection is passed, the first thing you're going to do is you're going to create a controller object here. After creating controller object, you will be checking if connection dot equals ignore case equals ignore case. If it is equal to MongoDB, then what has to happen? Then you are setting the connection set MongoDB connection. Let's say if the connection is equal to S3, then you will say controller dot set S3 connection. Let's say if the connection is equal to what else we left? S3 MongoDB, DynamoDB, then we'll say controller dot set DynamoDB connection. The connection is set. Now you will connect. I'm just doing connect and close together just to show you connecting and just coming out immediately. Here in the main method, you have something called scanner. So it actually initializes scanner for your input, which is your keyboard here. Once you initialize, then this is where you are asking user which database you want to connect to. Enter the database you want to connect to. So you asked him, and the guy gave the name. Since it is just a string, I'm using next. It is not a sentence. If it is a sentence, you can use next line. Then you are creating state program demo constructor and passing the DB name. That's it. Now let's see what happens. First I ran it. It is asking the database name. I gave S3. You see it connected to S3 automatically. It closed the S3 connection also. Now let's say first understand how it happens. Now what is happening is whatever database connection we are giving, that database connection, when we gave this particular database connection, in this case S3, is passed to the constructor, because this particular state program, it creates an object for the state program and passed it, and this is where it gets set. Here we are creating controller object, and based on this connection object is check whether it is equal to MongoDB. If it is equal to MongoDB, it is setting the controller.setMongoDB connection. What is that controller.setMongoDB connection will do? It will set your connection variable with the MongoDB instance, this one. If you see in the controller, when it calls, it is already set all this, right? And controller object is created here. That means when it is set, you have different instances already available. When you say controller.setMongoDB connection, you're just setting the state of your object to MongoDB. Okay, that's what happening here. And similarly, if you say connection.equal case S3, which is what happening now, the connection, the system state will be set to S3. That means once the system state is set to S3, that means if you call connect, it will connect to S3. It will call, if you close the database, it will close the S3 one, because your state is set to this S3. Now here what we are doing after setting it, we are saying controller.connect, we didn't set S3 and all. So automatically what happens is whenever you say controller.connect, so the state is already set. What is the state? The state is set in the connection here. If you observe, the state is set as S3, because you clearly said controller.set S3 connection, because your connection database name you have given as S3. So it is set. So once the state is set, automatically when somebody connection equal to S3, when it is set and when you call controller.connect and controller.close, what does it will do? Controller.connect, what it is doing? It is using the connection variable, which is nothing but it is set as a state as S3. So it will connect to S3. When you say controller.close, which is this one, since this connection variable, which is the state here, set to S3, it will close S3. So that is called state design pattern, because based on the state set, the behavior of the object changes. Okay, similarly, if you run it for, let's say, DynamoDB, now it connects to DynamoDB. So it is like your program is like neutral here. It is not doing any job. All it is doing is it is just calling a method, which is the controller here, saying, hey, please change the state to this. So this particular state value, this particular method call is just to inform to controller, hey, please go and set the state. This is where you are setting the state. You're just calling them, informing controller to set the state. So once it is called, what is happening is this state gets set here. And based on the state, whenever somebody calls connect, it automatically calls that particular database which is set as a state here. It connects to that or closes, whatever. Okay, so only the state information you are saying I want this, and it is set as a state, and after that it is called. Like in this case, if you see S3, in that internally we can write a code where how to connect to S3, how to authenticate and all. And similarly for Mongo, there might be a different approach. These are all cloud, right? There might be a different approach for connecting. All that connection code or closing code you will write here. For user, it is like immaterial. All he need to do is, when user writes it, he will write a controller method like that for MongoDB, S3 and all, that's all. But people, you can have different people, one who writes for how to connect to S3 as this, here we just said connect to S3, but he can write the relevant code to connect to S3 by authenticating using the security credentials and all that. Similarly for MongoDB, some other can write it, DynamoDB, some other can write it. And if you are a team lead, you can just write the controller where whenever somebody creates instance, it will create all these different types of objects you have like S3 MongoDB, and based on whatever user choices, like in this case, if user choice is MongoDB, you are setting the state. That set MongoDB connection actually sets up the state saying now onwards the connection variable state is MongoDB. That means now onwards if somebody calls connect, I will call connect to MongoDB. If somebody calls close, I will close the MongoDB, because your state is set to MongoDB. Similarly, if you pass your DynamoDB, if the user choice is DynamoDB, then in that case what happens, uh, if the user state is DynamoDB, the state will be set to, here the state is set to controller.set DynamoDB, so it will be set to connection equal to DynamoDB. Now at the end, when he is calling controller.connect, it will call this controller thing and it will call the DynamoDB one. What is connection? DynamoDB. So it will call this particular object which actually performs the action of how to connect to DynamoDB and all that. Similarly, how to close will be taken care here. So here it is like these three are like abstract, become abstract to this guy. It is like individual guys can write this code, and as a lead you can write this code where it connects individually. So the state variable here, if you understand in the state design pattern, is this connection. This, once you set the state based on user choice, you are changing the state, and after that automatically it connects to the respective database. So that's what the whole point is here. Okay, so like that I have taken an approach of MongoDB, DynamoDB and S3. Maybe you can take care of other use cases, like apart from connecting to multiple database. Here the concept is simple. The state, you have to set it. After setting the state, when you call anything, it should, I mean, uh, your system should flow through that direction. Now maybe just like that you can extend the code by putting it MySQL whatnot, or you can say, let's say for example, you can have different codes. Like let's say you want to have a piece of code based on whatever user inputs of code, you want to execute using Ruby, or you want to execute using Perl, or you want to execute using C++. So those three you can write it as different classes, and the state will be set as this programming language I want to execute the code. Like if you look at this use case, where it will be useful, if you think the hacker platforms, if you see these hacker platforms or Geeks for Geeks, they have a choice to choose the program, saying I'm writing this code, you have to execute in Python. I'm writing this code, you have to execute in C++. They will choose it, they will give it as a top down button, right? That use case clearly fits here for the state design pattern, where you can just give them different platforms, where one for Perl, another for Python, C++ and all, and based on the user choice, which is nothing but the information he's passing, you can set the state and automatically the relevant code can be executed. Like that, if you think, a lot of use cases can be implemented using state design pattern, because it is very advantageous in the case that you check the state and automatically different things can happen seamlessly. Okay, I hope this helps. Thank you.
So let's discuss about what we have learned in this design patterns module. We discussed about what exactly is design patterns. It's more about, based on the experienced developers, they have come up with certain patterns using which if you code, your code will be more robust and manageable and extensible and scalable. That's what the whole point is. In this, we understand about the standard three types of design patterns, starting with creational design pattern, behavioral design pattern, and structural design pattern. So we also discussed about J2E design patterns as well, where we understood about what are the different types of design pattern comes in. So these design patterns, like we discussed in the module, these are program agnostic. That means they are not related to any program, and you can use these design patterns in any programming language. It's not just Java. They are like portable enough to use in any programming language by themselves. So that's why these are very helpful. So keep these in mind when you're writing code so that you can develop much more better programs. So that's what